maybe some good research going. Feels validating a little bit to see some of the stuff that y'all are working on, particularly Kuzni. We were looking through some of your stuff and thinking, oh man, it's like same wavelength, things like that. But what I'm going to talk about today is the study we're working on is the effects of interruptions on situation awareness in multi-vehicle supervision operations. So I just wanted to put this kind of in the context of the project that we're doing this for. So this is for the TQ-RAM subproject, which is not only supporting the working group, but it's also supporting our research. Garrett's going to come up in the second year and talk about some of the stuff he's working on, which is led out of Ames. We're collaborating with them across center project. And Sienna Whiteside, she's leading this group now. Previously, this was Vanessa. She's Vanessa Alsham. She's at the TQ project management. So before Mike and I kind of talked about this a little bit. Before I get into the actual study itself, I wanted to provide a little bit of context of the type of research that we conduct, which maybe this group isn't exactly familiar with this particular type of research, at least not all of you. So our group is called the Human Autonomy Teaming Foundational Research Activity, and so foundational is the key component in that. My background is in applied experimental psychology and human factor psychology. So when I think of basic research, to me that is tightly controlled laboratory studies. A lot of times you'll see this kind of stuff conducted in academic settings where you can put students in front of a task and see if they can notice the red button and how fast they're pushing it and how accurate they are, that kind of stuff. So it usually gets at theory development and those types of things. So they're not going to be targeting any one specific use case. This is the type of research that's like, I've got a set of parameters here. This is what you can kind of expect the human to be able to handle in these types of situations. So it's going to generalize across a whole bunch of things. Okay. That's not to say we don't do applied research. The thing about doing this type of research is it has to have some sort of like ecological sensitivity to the type of environment you're trying to generalize to. So for the past couple of years, we've actually been doing a lot of very applied research with like Brian Petty over there in the type of work he's been doing with remote operations at the Rome UAS Ops Center. If y'all haven't been out to Langley to see that, I highly recommend it. So we were able to pull out a lot of aspects of tasks that we then abstracted down into things that we can put in front of folks and get generalizable principles. In addition to that, a lot of what this research came out of that I'm going to be talking about today grew out of the working group meeting. We had a lot of conversations that after several meetings and what we think everyone's sort of facing different problems. And we tried to kind of boil that down into a study that maybe addresses some of that. So just keep in mind, psychologists, basic psychologists in some cases, so the task's not going to be super applied. All right, so now that I've taken, 5 minutes to set the task up, this is very short outline. I'm going to go through a background, talk about the philosophy of why we went for what we went for, and then I'm going to kind of push into the method section, and Mike is going to talk through a video. I could talk to a bunch of slides on this. It's probably much easier if you guys just saw what participants are seeing. And then I didn't want to go through the initial, we kind of toyed with, we've got some initial findings. We have an N size of 8 right now in our study. We got to get to 30. I don't know how much those results are going to hold up. So I didn't want to put anything in slides, get held to it, see it on Strives later or whatever out there later and have to invent something. And then we'll just close out with conclusion. So bottom line up front, the objective of this study is to investigate the effects of interruptions on situation awareness in multi-vehicle operations. The way that we're going about doing this, though, is we're essentially having participants do a system monitoring task in a multi-vehicle operation paradigm, right? And then we are going to then systematically interrupt them to see what those effects are on their situation awareness. And we measure situation awareness with an objective measure. So either you know what is happening in a situation or you don't. Like, what's the altitude of this aircraft? If you know it, you know it. You don't, you don't. So we were able to kind of like actually key in on that construct. Again, the purpose of this research, the impact is, we're not going to solve any one specific use case. What we can do is provide generalizable recommendations that hopefully will be applicable across a bunch of just multi-vehicle operational paradigms. Okay, so obviously this is in the advanced air mobility domain. There's a lot of subgenres in this. we picked UAM just because of basically all this is going to impact with is mostly on the task, what the kind of operations they're looking at. So there's bigger vehicles, they're going to move at a different speed than some of the smalls. But other than that, I mean, it's a very similar design paradigm to what we saw yesterday and what folks at Zipline presented yesterday. It's sort of probably generalizes to those types of operations as well, but for our purposes, we just chose the air taxis. So this is obviously the end-to-end working group. I'm not going to try to go into depth and explain what exactly that is. It's basically, I think we all kind of agree, it's fewer human supervisors managing a whole lot more vehicles. And the way that we accomplish that is, there's like a vehicle handoff component to that, but really the big underlying bold point is increasingly autonomous systems. And that's kind of, it's turned itself into kind of a phrase, but a lot of autonomy, right? Automation, high levels of automation across the system. And that sort of enters into this really, the key point that we keep coming back to is this trade-off between.
Oh, you need to come here. Capo, where are you?
It's right here.
Oh, why won't you come? Oh, okay.
Is that Wendy? Hi, Wendy. Okay, so we've got this thing we keep coming back to, which is this ever-evolving switch between the notion of responsibility and authority. And so, although we haven't been looking at multi-vehicle operations for a ton of years, this particular design paradigm, this has been studied for decades, right? Like Tom Sheridan has been studying this for a long, long time. It's a supervisory control paradigm where, if you think about it, it's sort of like if I'm a supervisor, I'm overseeing some employees, these like their vehicles, I guess. I'm not getting in the weeds with what they're doing day to day. I've got high level tasks that I need this done, I need this done. They're going to get it done however they're going to do it. I'm going to step in where I need to make changes to plans. If there's some corrective action I need to take, stuff like that. That's the role of the human in those things. So this is not a new design paradigm. The only layer on here is just that, okay, this is in a multi-vehicle type operation situation. So when I think of multi-vehicle operations, usually, especially in places like this, where it's like you look at the human factors guy and you say, all right, what's the ratio of what's this golden ratio that I can get to, which I think is the conversation we were having the other day. That can be problematic because I get asked that question too. I'm like, I don't actually know. Like that's the whole thing. But what we're really all talking about is trying to get to scalability. I think that's the key crux of what we're trying to get to. Asking the ratio is not actually probably like the right question to ask, because going through the literature, I mean, like there's, wait, am I right? Yeah. So like people have been looking at this for a couple of decades now, where how many things can they control? And they've been actually trying to answer that question. And the really unsatisfying response to most of it is, it depends, right? Like that's the most unsatisfying response to get from a human factors person, is it depends. But what does it depend on? Basically, the only consensus that I can come up, we did like a giant lit review on this, is the more automation you introduce, the more stuff you can have them monitor, essentially, right? And I was able to cite Andy's paper there, like a paper you guys wrote with, what's it, Zipline, and I got the 1 to 24 that I was able to pull out. Talking to Mark yesterday, I asked, like, what's the upper limit? There is no upper limit. It's like, tell me what I can do and I'll do it, right? So what does that depend on? That's just level of automation introduced allows me to do more stuff, right? But the thing we need to be careful with that is essentially what you've got going on is you now have a human who is responsible for a bunch of automation that actually has the authority to do the thing. So that's kind of the key point. We've pulled a bunch of stuff from Andy's papers on this. If you haven't read any of those, I highly recommend it. So that brings us to, okay, then what is this person? We were calling him the RPIC yesterday, and I apologize if I say operator multiple times in this and you start flinching. It's because we call our folks ground control station operators, so I just shorten that to operators. Yeah, so when I see you blinking over, I'm like, okay, sorry, I gotta stop saying it. But I like the term multi-vehicle supervisor for this reason. Supervisory control, it kind of lends itself to this, right? So the way we sort of broke this down was traditional manned operations where you have a pilot flying and a pilot monitoring. Well, what we're doing in this case is we're kind of flipping it on its head where the pilot flying is actually the automated systems, right? Those are your pilots flying. They're actually doing the thing. They have the authority to do all that stuff. The pilot monitor in this case is the one that is responsible in overseeing all those types of operations. So we kind of dug down on, all right, monitoring is a task that is well recognized in aviation, and it's studied quite a bit. And so we kind of started really thinking on that monitoring role. Monitoring essentially, and so this is coming from some colleagues at Ames that have done a lot of great work into the monitoring task. Dora Billman, Randy Mumma, and Mike Fury. He's the one that's like the et al part that's in both of these things. But essentially what that is it's a sense making, right? And all that is systematic observation of interpretation of the current state of the airplane, in this case, plural airplanes, and the operational environment. And this significantly overlaps with the construct of situation awareness. If you can figure out what their situation awareness is, that's a pretty good objective measure, you know, you can get those, of how well they're doing that task of trying to make sense of the situation. And so I'm gonna kind of linger on this for a second, just because we've had a series of papers that we've tried to publish, stuff that we've done. We're looking at folks with Brian's group going through, and in the applied environments that we've been able to collect data in, we've gotten some feedback from reviewers where their main response is basically like, you guys don't have a performance outcome measure here. You've got a bunch of subjective questionnaires, and you've got some other things you're doing after action reviews, things like that. Where's the performance? I'm like, dude, they're not doing a whole lot. It's not that they're not doing anything, it's just nothing objective that I can observe, right? Like I can't get button presses and response times for a ton of stuff. Because if you watch these folks operate, they're staring at the screen intently. So we started realizing like that's where the money's at. Like we need to actually try to measure that somehow. So that's kind of why we sort of got into this monitoring is the thing. So our primary performance outcome for these folks is their level of situational awareness. It's what we're calling performance-ready situational awareness. And so when we look at that, one of the main threats to threats to monitoring performance is actually interrupting folks. And so when I say monitor or interruptions, think exceptions. Think, you know, when we were walking around the ops center yesterday, it's like that's not the only responsibility that they have, right? There's other things that are going on, even if it's like a sterile room. I saw chat boxes, I saw other things. They're not just staring at a screen. There's other responsibilities that they have to take care of, and that can be problematic for the effects on situation awareness. So let me so we're the foundational research activity. I have to just touch on theory a little bit here just to show you guys where that's more of our focus. I'm not going to get super into this. I think Micah Ensley presented at the last meeting, so maybe you guys got a whole face full of this theory for the whole time. But she's got one of the the mainly accepted most popular theories of situation awareness. Essentially, what it is, just you've got elements in the environment that you're perceiving is at level one. Putting those elements together, comprehend, sort of derive meaning from that, and then you can kind of project in the future what's happening. These don't have to develop linearly. If you're an expert, you have an excellent mental model for how these situations play out. You can probably guess really well in some of those level one situation awareness probes and sort of figure out, like, I don't know, they're in this area over here. I bet the wind's this or that. Even if you don't have that information, you can probably guess that. So having expertise in these types of domains is really important when you do study situation awareness. And I just want to make that point, so we have some hypotheses in around that. The other part of this too is there's already an experimental paradigm that's fairly well established in interruption management that we can kind of place onto this novel type use case that we have and study in a very systematic way. What you have is an ongoing task. In this case, imagine a system monitor, and then you get interrupted with whatever that other task is. It pulls your attention completely out of it, and then it's when you switch back to that system monitoring, what's the effect on that S2 right there? That's the place that we're most interested in. So you've got this kind of nerdy cognitive psychology model. If this probably looks a little bit more familiar to what to the paradigm that you guys are investigating, everyone's interested, right? Like you have this ongoing monitoring task. There's multiple vehicles that you're trying to pay attention to, and then you have other responsibilities. Inevitably, something comes up, right? You have to go heads down on a single vehicle. Maybe you're talking to someone, maybe you're messaging someone, you've got to do some sort of data assessment, any number of things. It's very use case specific. So we didn't really want to get into the weeds with that. And then as you're doing that, you have to keep that whole situation in your head and then switch back to the ongoing task at some point at time 2. And that's sort of what you end up with. Okay, this I definitely will not get into just because it's just a ton of theory. There's reasons why you think you might find some empirical evidence. Long story short with this eye chart is situation awareness does not like to be interrupted. It's probably not good. There's not direct research on this, but a lot of tangential stuff. Nobody's that we could find to study this specifically, but there's a lot of theory to back up that this is probably not great to maintain situation awareness interrupting folks. And so when we were looking at this, just kind of bringing this back, we wanted to think of a task that we could give anyone right in the middle there that was systematic. If we started going heads down, like really into like spatial planning, that could be a follow-on thing. Keep in mind, this is study 1 of, I don't know how many. But the type of task itself, what we really wanted to do was load working memory. And you kind of need that to be able to function throughout the day. You're doing something, you get interrupted, keep something in your head, come back to it. That's the use of working memory. So what we did here, instead of going and making some weird task in the middle, we pulled a cognitive psychology task called spatial NBAC. And all that does is just load working memory. So that's the interrupting task that we have here. Again, not going to get into the weeds with this, but we had a series of hypotheses of what we expected to happen here. Basically, the longer the interruption is, the more interruptions they have, the more of a negative effect that's going to have on their situation awareness. Higher workload, more vehicles, things like that. Not great. But one thing that we didn't make a hypothesis on, I think is important for this group to just for future stuff. Sam, if you're paying attention, just throw it out there as something to look into. Is the notion of vigilance decrement, right? So in our control condition, we're not actually interrupting anyone. We're just having them sit there and do the monitoring task. And I'm not actually sure if the control condition is going to be the worst group or the best group, because if you guys have ever seen these types of tasks, it's not fun to sit there and stare at a screen where problems don't occur, but you still have to maintain awareness of it. That's actually really hard. So a vigilance paradigm is you probably want to get an expert in vigilance decrement to come in here and talk about that a little bit, because I think it applies to the supervisory control environment that we've got going on, where there's not a ton to do, and you're required to sit there for potentially 4 hours straight monitoring something that for days on end has not occurred. That's really, really hard. Humans don't do well with that. Okay, now I'm going to fly through the method and send Nick up here to talk through a video. I did want to just briefly tell you guys who we're testing this. So we got to get to 30. You guys probably don't care about the power analysis, but we basically have to get to 30 to start seeing effects in a meaningful way. But the people we are testing is a range from anyone who is just Part 107 to pilots, right? Like just private pilots, which is the minimum thing. We just need people who are aware and can kind of interpret these situations. And we've got a pretty good gap breakup right now with 8. We've got 4 and 4. So we want to try and do that, but we're kind of full in that direction. So I just wanted to tell you who's in this study. Yeah, Michael will kind of walk you through this, but we have this ongoing monitoring task with multiple vehicles. This is kind of a description of the NBAC. If I tried to sit up here and just walk you guys through this, you would be totally confused. You kind of got to look at it. It's a pretty, once you get it, but it's kind of hard to describe. You may be interested in the experimental design we have. So we have a 2x2x2, and this is fully within subject's design. For those of you who aren't experimental design experts, that's basically like every participant's going to see every combination of these things, right? So they're going to see 2 vehicles or 4 vehicles, and then every combination of a long interruption length or a short interruption length, a lot of interruptions, not a lot of interruptions, and we boiled that down to essentially utilization time. How much of the time of this task are you actually doing the interruption rather than your primary monitoring task? So that's how we're kind of systematically trying to figure this out. The vehicles was actually not even, the number of vehicles, again, is sort of arbitrary to us a little bit, because, I mean, clearly you can do these types of, theoretically can do these types of tasks with multiple vehicles. So we just picked 2 and 4 because WISC, their ConOps has suggested like a multi-vehicle supervisor is going to do 3 vehicles at a time. So we just picked, we were clever, we did one above it. So. And then here's our dependent measures. The main one is the situation awareness global assessment technique. Basically what that is, you just freeze the scenario and you start asking them objectively, objective questions like what's the altitude of this aircraft, where are they going, things like that. We also are getting some subjective stuff like NASA TLX, which is a workload measure. And we're also eye tracking people. I think that's probably going to be the more interesting thing that we get out of this. And so Mike and Elliot and a colleague who's didn't make it to this one, they're really digging down into the eye tracking stuff of this, because I would like to pull out that situational awareness measure and start looking at that more sense making, something that's a little more objective. Well, SAG is subjective, but it's also interruptions. All right, with that, I'm going to stop talking and let Mike walk through this video here. So this is what participants are actually exposed to.
All right, so yeah, what you're going to see here is a shortened version of what participants see. So they pick their scenario, and then it starts this video playback. So they don't interact with the vehicles at all. They're just monitoring this video. And on the data tags here, can you pause it, Jonathan? All right, there we go. All right, so in this video here, each vehicle has a data tag with some basic information. And like Eric was just talking about, the number of vehicles is kind of irrelevant because it depends on what we're asking them to do with each vehicle. So we picked a set of information that we wanted them to observe that they could use their mental model as a Part 107 or a pilot to synthesize that information. So if I put someone here who doesn't know anything about airplanes, it's a little bit harder for them to understand what the winds mean relative to their ground speed. But we wanted people who could come in and kind of maintain that information, almost chunk it together using their mental model so they can maintain situational awareness easier and have those higher levels of situational awareness. So the information on here is the vehicle name, the battery percentage, the altitude, indicated airspeed, ground speed, and then the estimated wind speed and direction. So when they get their situational awareness assessments, which over this 10-minute video, they will get 3 assessments. So one happens at the end, the other 2 happen randomly in the middle of that. And that situational awareness assessment will ask different types of questions, either level 1, 2, or 3 situational awareness questions. So level 1 would be something like, what is the current altitude of vehicle 2? And keep in mind, they're not able to look at this during that question. So a pop-up comes up, they can't see it, which I'll show you shortly. And they have to answer, what is the altitude of vehicle 2? What is the ground speed of vehicle 1? So we're testing whether they have that information in their head at any given time. Because the assumption, that we're talking about here, and as we go to management by exception, as you're dealing with these exceptions, if you have a short period of time between exceptions, are you actually going into the next exception with situation awareness? Or are you going into it with nothing in your head about what's going on and you need a ramp up time to deal with that exception, which in our group, the IME interruptions or
Exceptions and interruptions.
Yes, yeah. That's kind of interventions and exceptions. That's kind of an unknown right now. It's like, do we include a ramp up time for SA at the beginning of that, or are they coming into it with SA so they can just jump right in and solve the problem? So when we conceptualize these interruptions in our study, we aren't saying, like Eric was mentioning, we're not saying that the interruption was an unrelated task or a related task or another exception. It could be anything. So we just want to see, as you're being pulled away from this environment to do an interrupting task, you come back to it. At any given time when we randomly test you on that SA, do you have that information ready? So performance ready situation awareness. All right, can you hit play, Jonathan? All right, yeah, you can just let it run through now. So this is, again, a shortened version. So you're going to see I think 3 interruptions and then the situation awareness assessment at the end. The NBAC task is a 3-back. So you have to remember the position of the letter 3 previous. So you'll kind of, it's again, hard to explain, not going to get into detail, but this is the NBAC. So letters appear and you have to remember 3 previous, what position was that letter in? And if it is in the same position, you click. If it's not, you don't click. And we trained them on this before, so they fully understand how that works. We're not just throwing them into this.
Before you ask, this has nothing to do with aviation,
Yeah,
period. It's literally just a cognitive psychology test.
and that is
That
the point. Yeah, we want to just kind of ultimately wipe their working memory, their spatial working memory. So we're trying to just totally clear that out. So when they come back to monitoring, they have to kind of reestablish that situation.
When did those tasks occur, the monitoring?
The interruptions.
Yeah.
So those happen. It's randomized where they appear, but that was our manipulation. So we had a frequent interruption condition and a less frequent,
Right.
and then a controlled where they don't get any interruptions. And then we also had different lengths of interruptions. That was our other manipulation. So either just 6 of those letters or 13 of the letters. So we double the amount of time for the interruption. So those were our 2 manipulations. And as you see, so this is the situation awareness assessment now. So this pops up randomly and they have to drop the vehicles onto the map. So trying to remember where those vehicles were at. Once they do that, they have it for reference over here. They're giving confidence ratings for everything they answer. So here's an example, closest current track angle direction. So basic, simple question about what direction is that vehicle currently heading in. And these are all timed due to kind of the nature of the study needing to be very fixed time. Closest track angle after the next waypoint. So that's more of a level 2 situation awareness. So like, do you understand what's going to happen after that next waypoint? Cruise altitude change at the previous waypoint. So again, sort of a level 2. It's not just on the screen, but do you know what happened before? Predict the headwind, tailwind in the next waypoint segment. So if you've been paying attention to the winds that are changing, you should be able to have a good guess of what it's going to be on the next one. And that's a projection. So that's at level 3. And then closest current ground speed, just simple ground speed for vehicle 1. And the questions are randomized. They get 5 each interruption, or each time the Saget questions come up. And at the end, we give the TLX as well. That's at the very end of the scenario. A lot of stuff to cover. Went very fast there. I think that's most of it. Let's see. Yeah, so could get into more details about this, but about the scenario specifically, but I think, yeah. At this point, we can answer any questions.
Well, so basically, I just have one more size. So I feel like I need to complete. So yeah, we're in data collection right now. We're going to be probably done with this in November. Now I'm going to take a break with my wife misses me. We like live in Moyock, so I'm like an hour away. Yeah, that's beside the point. But we're going to be probably doing write-ups going into early next year, and then we have a really big test plan that we're going to send. We're going to turn into a technical memorandum, and it's very complete. And then we're going to do like smaller versions, journal articles, things like that. Okay. So is there any questions on what we're going after?
So in this scenario, there are 2 vehicles, but they seem to be geographically pretty separated. Have you considered scenarios where you have a close formation swarm on airplanes?
That's a good point. So currently our manipulation is, we do manipulate the number of vehicles, so 2 and 4, but with the operations that we are kind of emulating here with UAM vehicles, we haven't considered like swarm, but that is, if you had a swarm of vehicles, that could affect your ability to maintain awareness of all those, because you can kind of chunk all of that together potentially. So yeah, an interesting potential follow-on study.
Yeah, just to keep in mind too, when we were going through this, we had like dozens of studies that we were like, oh, we should do this, we should do that, we should really start piecing it out. This is just number 1 of a very modular experimental paradigm where you could start investigating something like that. Like, are they actually able to do this if there's not tracks on everything and they're chunking stuff? Like, that's an empirical question. I don't know. Like, it totally dependent on what you put in front of them. So it's a valid question, but we don't.
What level of automation are you assuming for these vehicles? Because I think as a supervisor or whatever, that would change what kind of data I need to retain for all my vehicles.
That's a good question. So Yeah, essentially, we're assuming, they're fully autonomous, but the way we've designed this is that we don't need to necessarily make assumptions about what the human is going to have to do to interact with those vehicles, or like what tasks they have to do with each vehicle, because ultimately we instruct our participants about the situation awareness probes. So they know all those probes are coming, they know what information they need to retain. So that is kind of their level of like, what do I need to know in this environment? Rather than us kind of coming up with some random task for them to do with the vehicle, and then they do that thing and have the information. We generalized and kind of like got rid of that question.
I would say we didn't try to sit them down, hey, pretend that you're this person and doing this thing. It's more like, hey, keep track of this information, whether, this is the relevant stuff, keep track of this. You're gonna do this other task that's gonna interrupt you. We weren't trying to like pretend that we're in some high fidelity simulation in this. It's like,
So their task was basically to have situational awareness.
that was their task. Yeah.
Their task is to maintain situational awareness. They never had a task to do anything with the situational awareness.
Correct.
That's so.
Yeah, that's what you would infer from our study is, do they have a situation awareness to do another task?
But it might be that if they had another task that really required situational awareness, they might do better at maintaining situational awareness.
Yes.
Because there's a purpose behind the situational awareness.
Which
But
is,
that's a kind of higher order study that might happen in the future.
Correct. Yeah. Yes, and that's a great point. So, you have interruptions that are potentially related to what's going on, which could help you maintain situational awareness. You could have unrelated interruptions. There's some interesting findings in the literature. One of our colleagues at Rice, they did like a driving study with interruptions and found that an unrelated task actually improved someone's ability to perform in a takeover scenario. But the results on that are kind of, they found that, but it's been found that that's not the case in other studies. So they're diving further into that, but we don't know. So like if you're taken out away from it, you may be more inclined to like really come back up to speed when you come back because you know that you need to, as opposed to a related task, you might kind of like, all right, I'm back, I'm fine.
but to that point though, Andy, the way we got asked that question in our experiment review, and our response to that was, okay, but they are actually using that information to answer those questions. So it sort of became part of the thing where they were like, well, this is the goal. I need to like keep this in my head because I'm going to get asked this.
But I think your point is their task was situational awareness.
Right.
Their task was to complete that quiz,
Yes.
the situational awareness quiz. And so that's what they needed the information for. So that's why it's valid.
And yeah, so another point to make is, we're not talking about the vigilance decrement here, which is another problem. So
We would do a different study for that.
yeah, so like what we were talking about yesterday, when we saw the operators at Wing, like, if you don't do something for a long time, like you could get bored, especially if that goes on for days and days and days. Like at a certain point, you're not going to have that task in your head of like, I need to maintain situational awareness. Like over time, you can't do that. So very interesting problem.
I might have missed it. When you're asking or when you're doing the impact test, is the simulation paused and they're remembering where they were, or are they projecting into the future based on their like?
The task keeps going in the background.
Yeah, great
keeps
question.
rolling.
I meant to bring that up. But yeah, during the NVAC interruption, the task keeps going in the background. We're assuming they are doing something else where they're fully pulled away from monitoring, but it's still going on in the background, and then they come back to it. But the interruptions are, I think 14 and 28 seconds. These vehicles don't move super fast, so relatively little movement during those.
But controlling for time for the impact, like is it projected at the same time?
Yeah, so that's one of our NVAC manipulations are specifically 14-second interruptions for 28-second interruptions. And we kind of randomize with the normal distribution of when they happen. So it's not like exactly every like this many seconds you're going to get the next one. There's some noise in there so that they can't anticipate it.
So why are we assuming that humans are good at monitoring functions? It seems that that's really where the automated systems should be doing stuff. Because humans are much better at decision making and very poor at monitoring. So it seems like we're doing things entirely the wrong way around.
Well, yeah, so that's a great point. The the reason we are studying this is because despite knowing that, we're still
We're
putting
still
humans in
doing it,
situations
yeah,
where they
right.
have to do it.
That's, yeah.
We don't have control over whether
Yeah,
a company
we're
wants
not,
to do that.
we're
or
not like saying you should do this. We're just saying like, this is what will happen if you do this.
Yeah, we're trying to figure out the performance of a human in this situation, so someone who's designing a system can make an informed decision that, oh, they can't do it this way, that well.
Because even your description of the experiment is stressing me out. And having to maintain situational awareness on all of this stuff.
Yeah,
Without necessarily having to make any decisions or know what to do.
I mean, also anecdotally, these people are ready for lunch and they are ready to leave. At the end of the day. Like if you've ever done an NBAC task, it's like not fun after a while. And if we do this to you for 4 hours,
Yeah.
by the end of the day, they're like, okay, this study was fun. I'm like ready to go home.
Yeah,
Like,
so they're 10-minute scenarios, and we do 10 scenarios over the course of the day. So it's like, it's exhausting. And in that 80% utilization, basically, they are doing NBACs with 5-second windows to look at the screen, like the monitoring task, and then being pulled away again.
And I see Jay.
Yeah.
So you can blame Missy Cummings for that. We basically pulled this utilization rate for her for the task she did. Again, that was for performance, not situational awareness. But we basically like reverse engineered that from the 12 missile monitoring task that she had. I was like, okay, let's just mess them up for 80% of the task and see if that does that. We just wanted our DBs to be sensitive to the manipulation. And
They will be.
yeah,
It's almost another control condition where like we're just like, there's no way you're going to do well on that one. We're just going to like overload you.
We should probably move.
We can chat later if anyone has more questions.
Behind you, Jay, that's one.
Oh, yeah.
Sure.
I actually have 2 questions. I'll make them quick. One, do you have a minimum performance on the impact test?
Yeah, so we do, we're doing outlier labeling, real statistical type, like, basically we're looking to see if like, were they so bad at this that they probably weren't doing it?
And so that's
Yeah.
what I would do. I would just ignore that.
Yeah. So, yeah, we're gonna, and we tell people to prioritize both tasks, like, don't prioritize one or the other. So, and we'll be able to figure that out.
Okay, and then 2, after your tour yesterday, saw our operations. Did that change your perspective on us at all? I'm just curious. I mean, I have a lot of calls, so I'm not gonna go into all of them, but.
No, if anything, like, I was like, we're like maybe on the right track here a little bit, but maybe we're not.
I mean, we don't train our people to look at it if they're.
Yeah,
That's the other thing, yeah.
That's pretty eye-opening to see like, you're not asking them to do this. Like, they don't need to keep SA on every single vehicle necessarily.
Right.
Or they don't want to.
Yeah.
We just weigh information.
I think that's, yeah.
They need to keep SA on the airspace of the monitor.
They need to-
Right.
they-
So it's a different, they're monitoring a different thing.
But it's still SA, so that was our,
Why didn't you pick the wildfire scenario?
that gets a little into like a specific use case, I guess. We were trying to stay as like away from that as possible to provide generalizable type. So like if we got really into that, like a use case thing, we would probably design this a little differently to see sort of the effects. But then it would generalize to wildfire scenarios probably. Sorry, I'm trying to get us back.
Sorry, Gary.
Jonathan.
Yeah.
Yeah, sorry.
Thanks, guys. Appreciate it. So now we'll have Garrett Sadler talk about some work that's going on at the HAT Lab out at NASA, and I guess in conjunction with the Rome Lab as well.
Right now, fortunately, Eric went through some literature review that I have on my slide, so we can kind of skip through some of that. So that's nice. Thank you for doing that, Eric. Yeah, so you just heard about the study, the Draco study that Eric and Mike are leading at NASA Langley. And I'm going to tell you about a study that we have planned to run targeting data collection for early spring of 2025. And so this falls in the Transformational Tools and Technologies project. I think we're all familiar with this same sort of pedigree as they were going through there. But I, together with Megan Sapon and the PI of the HAT M2N activity, which is sort of the counterpart of the HAT foundational activity, but we really do our bread and butter has been running human in the loop simulation research, where we look to see how can we augment human performance with increasingly autonomous systems. We don't want to replace the human, we want to increase their capability. We use a design philosophy where we want a relationship between the human and the system that is inspired by sort of a teammate collaborative kind of relationship. And our overarching goal is to test and enhance the safety and efficiency for novel proposed operations that are going to interface with the National Airspace System. Also similar set of slides to start things off. So for this, for our high complexity sim, what we really are wanting to do is to investigate system level effects of operational disruptions, in particular disruptions at vertiports on end-to-end UAM fleet managers, and sort of what will be the resulting impacts on system resilience. The approach we're going to take for that is to do a human-in-the-loop simulation with multiple UAM operators, as in big O operators. I will also try to not make Andy wince with doing, I'm going to stick to trying to say RPICs for that. But yeah, we'll have multiple UAM operators, one being people in the HAT lab at NASA Ames, and another operator played by folks in the Rome lab at NASA Langley. And we will be introducing disruptions at vertiports in a hypothetical vertiport network in the Denver, Colorado area. And what we will be measuring is impacts to system capacity, and efficiency, and resilience. I'll get into some of that more in subsequent slides. And our goal here, this is a bit of preliminary research. Our goal really is to get a characterization of these kind of system level effects of the capacity disruptions. And we want to get insight into maybe cascading effects of those disruptions, maybe emergent behaviors that come up, system recovery times, and impacts to human performance. And so I'm going to be talking about capacity a lot, so maybe it makes sense to clarify a little bit of what I mean by that. And so by capacity, we're thinking of a throughput model of capacity, where capacity is the number of operations that occur at the vertiport per unit time. And by number of operations, I mean the sum of basically takeoffs and landings at the vertiports per unit time. Looking back at the literature to see how you define capacity and determine capacity for airfields in traditional aviation, you'll see kind of some that discuss a theoretical maximum capacity, that is the maximum number of operations that could be accommodated at the airfield per unit time. And then there's also the measured capacity, the published rates, what is the actual number of operations that occur per unit time. There are a couple of documents that I mentioned here that kind of get into methods of determining capacity for an airfield, kind of an a priori analysis. And I put it up here mainly just because I'm interested to see if there is research. I looked around and didn't find a lot on this, but if there's been research on the determining theoretical capacities for vertiports given different kind of vertiport configurations. I know in the UAM ConOps 2.0 document, they talk about different operational tempos and mention numbers like 1 operation per minute or 60 operations per hour. But if anybody knows of research into kind of theoretically determining capacity for vertiports, I'd love to hear about it. And we have some other metrics related that we are going to be getting into. Oh, I should mention, so yeah, the theoretical capacity is interesting, but what we're going to be doing is measuring the capacity of the DV rather than trying to theoretically determine something. And in addition to that, we're going to be looking at efficiency. And by efficiency, I really mean when these disruptions occur, what are going to be like the number of delays, what are going to be the magnitude of those delays, average magnitude of those delays, capacity, the number of operations per unit time, and then cost effectiveness. Here, we're really going to be thinking about, what's going to be the increased cost to operators when there are these disruptions. Heuristically, we're just going to kind of assume that time is money, and so that more time in the air is a greater cost to the operator, and so you could get maybe a percentage increase of the cost versus what was originally planned. I'm also interested in the cost to the consumer too, and so there have been various consulting firms and universities that have suggested kinds of fare rates for UAM operations that typically take a structure of like a base fare plus some amount per passenger mile, like $5 base fare, $5 per passenger mile. And so I'd be interested in seeing, what's going to be the impact on the consumer's cost when there are operational disruptions as well. To give you some background on complexity, well, some of these bullets kind of were reviewed by Eric already. The N kind of does lend to complexity, but I think the consensus that we've had from this group, right, is that the N number isn't exactly the thing to focus on. It's the number of interventions and the rate of interventions. It may be that that number and rate of interventions scales in proportion to N, but that may not be generally true. But in any case, N does lend to the complexity. There's also complexity in the decision making. Sometimes you might have many decisions that are going to depend on each other. The outcome of one decision might affect a future decision. And so you have to go through in kind of a decision tree, looking through things. And we know that inherently in M-to-N kind of situations, there is task switching and attention switching, which has that complexity has impacts to the situation awareness, and interruptions would also have an impact there. And then we have seen in the literature that workload is sensitive to N, but I think that's also because, as I mentioned in a lot of studies, I think it's because the intervention rate was scaling in proportion to that N there. But that may not be generally true. It may not be true for example. But also, lending a little bit more about complexity, I was happy to see in Husni's slides on Tuesday, he had a kind of breakout that was a little bit similar to this, a little different, but a lot of overlap in what are sort of elements that lend to the complexity and what are we thinking of having lend to the complexity in this HITL. And that is, you know, complex environments, complex situations, and complex capabilities. And to elaborate sort of what I mean by those things, for a complex environment, you might have multiple end-to-end parties, multiple big O operators together in the same airspace. Those operators might have different kinds of ground control stations. They have maybe different internal procedures and protocols. They may have a heterogeneous set of fleets, or there might be different kinds of vehicles in the air. There might be different use cases operating also in some common airspaces. For a complex situation, that maybe situations that involve coordination among or between operators. There might be situations in which there are non-constant personnel and shift changes. You might have simultaneous contingencies come up, and situations really where you need to weigh multiple factors at once, where you have to do some of that complex decision making. And then what do I mean by complex capabilities for M-to-N? Well, yesterday the topic of systems kind of came up. And what I'm meaning for us here is our remote pilot and command will be needing to use compositions of different capabilities to manage the situation. So handoffs, using their comms, using maybe plays and other kinds of automation to work through the problems that arise with the capacity disruptions. So I won't give you an entire oral history of what we've been doing in the HAT lab to date, but we've run a number of studies. And to give you an idea of what's in our HITL basket so far, these have been things that are part task simulations, so we haven't been doing full missions. Most of them have been kind of a 1-to-N rather than M-to-N more generally. All of them have involved a single big O operator. And we've really focused atomistically on one kind of feature or capability at a time. Did a sim about handoffs, a sim about comms for managing multiple UAM vehicles, and sim on using plays for contingency management for small package delivery operations. But I think we're at a point now where it's time to start combining these elements, go to do full missions rather than part tasks. And when you start combining and increasing some of these elements, what's going to work well together and what's going to start to fall apart as you go from looking atomistically to molecularly. So we don't do this in a vacuum. We have a community sort of informed approach. We have partnered with folks from industry to consult with us on the design of our studies. And so in the past, that has been Joby and Zipline. And we also currently are working with folks over at WISC to consult on our designs and also brief them on results and kind of help consult on some of the work they're doing. And we also engage, such as with the working group here, where, as Jay mentioned, I think yesterday or maybe Tuesday, one of the intentions of this group is so that folks like us at NASA can hear from the community what sort of research needs there are, and then come back later and tell you about what we found. So with all that, now I can get you into some of the experiment design of the high complexity sim. And so, as I mentioned, this is a little bit of repeating myself, but our objectives are to characterize vertiport resilience when you have multiple operators experiencing disruptions at the vertiports. We want to look to see and discover any emergent behaviors there might be in simulating two different capital O operators, and get also generally feedback on some of the utility of our UIs and tools. As I mentioned, this is preliminary research, so we don't have a long list of hypotheses, but some of our research questions are, what are going to be the systems level impacts to the disruptions to the UAM operators? How do their responses to those disruptions affect the system? How is the coordination between operators affected? Are the operators affected the same, or maybe are they affected differently? And if so, why? Does a corridor assumption, a UAM corridor assumption, affect the magnitude of the impact? And what is the recovery period to return to sort of a nominal kind of rate of operations? And then we also have some of the human performance kinds of metrics and questions that we look into in our HADOS commonly. Like, what are going to be the effects of disruptions on, say, situation awareness? We won't be doing SAGIT, but we will be using SART instead. We don't want to pause our simulation, especially because it's going to be a distributed sim with two laboratories. But we'll be using SART for subjective situation awareness, NASA TLX for subjective workload. We'll be looking at stress and also some response times to performing actions. So we are looking at running a 3x2x2 mixed subjects design. There is an asterisk on the 3, which I'll mention more about in a moment. But the variables we will be manipulating are the scale of the system disruption. So in our low system disruption, we'll have one vertiport that is affected. In our network, there'll be 11 total. So 1 out of the 11 affected. In the medium condition, 2 vertiports affected. And the high disruption condition, 3 or more vertiports affected. And in the next slide, I'll tell you about what those scenarios might look like to create those disruptions. We'll be manipulating also the M-to-N ratio, having a 2:6 ratio and a 2:12 ratio. And then our between subjects variable will be a corridor assumption. So we'll have a group of participants that run with corridors, and then another group of participants that run those same scenarios, but without the corridor assumption. We're going to block these by the M-to-N ratio, and we're looking to, ideally, I would like to recruit folks from the Part 135 world, the passenger carrying Part 135 world. And I was glad to learn yesterday, Tim, the distinction between what is a package delivery and a cargo. That was very illuminating. We're looking to run 10 total subjects, and the scenarios themselves would be 45 minutes in duration. So there's that asterisk I wanted to get back to, and that's because we are running this with 2 labs that are on opposite ends of the country. We'll have, one operator will be the HAT lab, another operator will be the over at the Rome lab at NASA Langley, and this study will actually require 2 days of participation for each participant. And as a result of all of that, it's very high demand on the staffing levels of these 2 labs over a long duration of time. And so depending on how that kind of impact of occupying the lab, we might have to eliminate that medium disruption condition, and this might become sort of a 2x2x2 as opposed to a 3x2x2. As I mentioned, the stories for the system disruption would be in the low system disruption case. These also come from the HDV project at NASA and their high density automated vertiport concept of operations. In our low system disruption condition, the story is like a partial vertiport closure where you have a disabled aircraft on a landing pad that is partially closing part of one vertiport. In the medium system disruption, there are 2 vertiports affected, and the story we've been thinking for that is a sort of degraded GPS environment situation. And then in the high system disruption, this taking place in the Denver, Colorado area, the story we're thinking for that is that there's a thunderstorm that comes up that causes a temporary closure at 3 or more vertiports, and you can see a mock-up of what that might look like when you have a thunderstorm over some of the vertiports. To show you what our sim environment will look like, that table really formatted funny. Apologies for that. But we will be running scenarios that have a corridor assumption and others that don't use corridors. So in the non-corridor version, this is sort of our map where we have each of these smaller blue circles represent vertiports and the vertiport operations areas for them. Those vertiports will be at Arvada, Aurora, Boulder, Broomfield, Centennial, one at Denver International Airport, downtown, one kind of on the border of the Englewood and Lakewood neighborhoods. So we've made the portmanteau of Engle Lake, Lafayette, North Glen, and Reunion. And so in the non-corridor version, these UAM operators will be flying kind of VFR-like, probably more or less straight line from one vertiport to another, but there are going to be areas in which they are going to fly through some controlled airspace there. And that's where the bright sort of baby blue borders indicate is areas that are in controlled airspace. And so if a UAM operation has to go into one of those vertiports, they will have to get prior authorization from the relevant ATC authority before they can go in to enter that airspace. In the corridor version, we will have corridors that act as segregated airspace. On my next slide, I'll show you what the kind of dimensions of the corridors are like, but there's essentially 2 lanes of travel that go, that are laterally separated. And I apologize, I'm trying to make sure I can wrap up so that people can get out of here on time and then get to the industry panel. But our corridors will connect end to end any pair of vertiports. You'll be traveling within the corridors for that. The dimensions are 1,500 feet laterally in one of the lanes, or 3,000 feet end to end on the corridor, 500 feet vertically. And as I mentioned, any pair of the vertiports in our simulation will have a path with corridors connecting them that will keep people in segregated airspace. So for our metrics, we will be looking at some of the just background on some of our pilots, their experience level, and then we'll be getting into sort of the local end system performance. So what are going to be, the capacity impacts at each vertiport, and what are going to be capacity impacts in the system as a whole? What is going to be the efficiency impacts at the vertiports and over the system? What's going to be the overall increase in mission cost because of the disruptions? And again, using sort of a heuristic that time is money and more time in the air is a greater expense. And then what is going to be sort of the rate of recovery from the disruptions? And we'll be looking at similar things for each operator, and by operator, I mean the big O operator. What's going to be that operator's hit to their capacity, to the efficiency? What are the delays going to be like for the operator? And what is that operator's mission cost increase going to be? We'll be measuring some human performance metrics, TLX for workload, SART for situation awareness. We'll also be using galvanic skin response sensors for stress levels. We just got some cool Tobii eye tracking glasses that we're going to be using for things like gaze and gaze fixations. And we'll measure service and response times as well. We're planning to collect some queuing metrics also, so that as people in response to the disruptions, are they going to have tasks that start to build up? And if so, what are those waiting times for those tasks going to be? What's going to be the queue length over the duration of scenarios? What's maybe the maximum queue length that we'll see with our participants? And then at the end of the day, as we typically do, we'll do a semi-structured, informal debriefing interview with our participants. We have a relatively low number of participants on that, on the experimental design slide. There was 10 total that we intend to run. So there's going to be really low statistical power. And as a consequence of that, there really won't be like inferential analyses that we could run. So we plan to brief out our descriptive statistics, broken out by scenario and condition, and maybe by some demographic variables of our participants. We probably will run like ANOVAs and stuff, but the power won't really be there for anything like to really infer. And then we'll be doing qualitative analyses, thematic interview analyses on our debriefing interviews with our pilots, and looking at the emergent behaviors. And for our timeline, I mentioned we're looking at data collection early spring of next year. So this is a proposed study. We haven't run it yet. And so we are on track to meet that data collection schedule. Right now, we're currently doing a lot of software development and scenario development. And then the plan is to do some internal briefing with our project, then potentially brief this group, maybe around this time maybe next year, and to produce some conference papers and potentially articles as well. And that's my last slide. 3 minutes past 10 o'clock, but
Yeah,
I can
we
maybe
take
take
like
some
5
questions.
minutes for questions. If it's-
So this is human autonomy teaming, right?
Yeah, yeah.
So I have a couple of questions about the teaming concept. So where is the quote unquote teaming concept?
Yeah, there's not a lot of it in this study. Generally, where we want to go with things is looking at potentially having some interaction with kind of maybe an agent, some autonomy agent of some sort, but there isn't a lot of teaming in this study. So that is a very astute observation.
That's what I was curious. That was my second question on the team thing. Like, would it be some sort of a teammate, an agent, an autonomous AI-based agent, let's say, for sake of discussion, who you could offload certain tasks when you have to go address something an exception that comes up, and you say, can you take care of this for me for 2 minutes while I come back, that kind of thing?
Yeah, I think something like that. I think, as I mentioned, this is preliminary research. I'm thinking of as preliminary. I think we want to do a high complexity 2 that would follow on, and that would be maybe an opportunity of, depending on what we learn here on what kind of cascading problems come up, maybe there is some opportunity for an agent or something else to help mitigate the situation. Nelson?
I would like to take that question to the industry panel because you know, the folks that have, you know, yesterday we saw that we had folks in the office, but we also had crews at the nest who were out, you know, doing recovery and things like that. But I imagine there's other con-ops that have different delegations of roles. That,
Very specific to the operation.
yeah, but I think we kind of, I don't know if that's something that's proprietary or they could share, but I would like to put that question.
All right. Oh, sorry.
In this level of decision making, what assumptions are you making for UTM, the involvement of UTM? And
Yes.
second question related to that is, how much are you assuming in terms of contingency plans that were already in for some disruptions? If you have a weather system on the wind, for example, it's not very quick. People anticipate that, and there could be some contingencies built in there. If it's a disabled vehicle or diverted port, that might be more sudden, but there could be something. So are you making any assumptions about, or is it going all manual? If something happens, we haven't planned anything yet.
So for your first question, so we'll be in the corridor version. We will be using a simulated PSU for doing strategic separation, and so the flights that the RPICs have to manage will be determined in advance of the scenario. So they'll kind of show up and they'll get a list of these are going to be the flights that you have over your shift, and we'll be using strategic separation through Freddy, which is developed in Code AF at NASA, and so that's what we'll be using for our traffic management in the corridor version. In the non-corridor version, there'll be flying VFR-like, but in the conditions when they need to go into controlled airspace, they'll be coordinating and thinking this is going to be using sort of a digital chat kind of thing. So this is looking at a future state of things, but coordinating with relevant ATC authorities there. And then on your second question, don't think we're going to be prescribing kinds of standard contingency responses. I'm really interested to see what our pilots do in response and have them creatively kind of work through the situation. And maybe depending on what we learn from having our pilots manage it themselves, we might be able to then figure out some recommendations on those kind of procedures for managing the contingencies that could go into a future study. But I wasn't thinking of prescribing kinds of what they do in their response.
How are you controlling the vehicle motion? Do you have a back-end simulator? Or what,
Yes.
What's that called? How do you press the go button?
Yeah. So we will be our test bed in the HAT lab is Vigilant Spirit Control Station, which is created by the Air Force Research Lab. But we a handful of years ago received the source code and have been heavily modifying. As part of that, we also have a simulation component to it where we can inject events and disruptions and kinds of control what the participants are seeing on their screens. So the GCS is going to be simulating the motion. People won't be doing any kind of like stick and rudder flying. It'll all be pre-programmed waypoint to waypoint flights, but that will be simulating the motion. There really isn't we don't have a really advanced physics model for our aircraft in that simulator. It's kind of a point mass kinematics kind of thing. Theoretically, we could plug in a more detailed physics model, but we aren't using one currently. And then also at the at Rome, at Langley, they have their own ground control station called MPath. They'll be using it. So those two GCSs will be talking to one another over NASA's network.
Okay, thanks, Garrett. Appreciate it. So now we're going to move on to the industry panel, and we got to get a few chairs on here.
George Ruff. Thanks for participating.
Hey, how's it going? Josh. Hey, nice to meet you.
Meet you.
Hey, Josh.
All right. I think we're getting down to the third day, and we've already had some really great conversations. My name is George Grosby. I'm the technical lead for the Autonomous Systems Discipline at NASA Ames in California. Today we have Chad Healy from Reliable, Josh Gordon from Zipline, and Mark Banks, in addition to all the wonderful things he's done this week for us, has agreed to be on the panel today. I want to paint a little bit of context at the very beginning of this. We are in the process of visioning for the future of what the working group is going to become. I think the forefront, we've got some questions about where to take this next, what types of problems we want to focus on next. And also, I think it's a good time to reflect on the progress on our progress putting together, first of all, this really great community, coming together and building some sort of consensus, if not around specific terminology, which still needs to happen, but also identifying issues with specific use cases, and then evolving that into work on key barriers towards program and operations, and then the white papers, of course, is what I'm referring to. So this is a cool opportunity for us to really think about things like what has your participation in the M10 working group helped you personally with your role in your organization and your organization at large, and in the future, how can we continue to provide value to yourselves? Maybe it's a good way to get started here. The easy one, I suppose.
Where do you want to start? Just anybody?
Yeah, anybody.
Yeah, I can give my perspective. So I think this is I remember Jay, how many meetings have we had in this group now?
Dozen?
Yeah, I don't know if I was on the first couple, but I think I've been at 4 or 5 of them, something like that. That's been interesting. You know, I'll be perfectly honest. Like the biggest value to me has been basically forcing me to try to put together arguments, articulate a position that was nebulous beforehand. Like, could come in and just be like, "Oh, I don't agree with y'all," but that doesn't really do anything. So we gotta actually having to put together a counter proposal. I think was really helpful for me personally and for our company. Like, what do we care about? What is our agenda? A lot of times we're so busy stuck in just trying to get Tim in the back to say yes to something. We don't necessarily think long term about what is the strategy by which the industry as a whole might evolve. So I'm going to ramble for just a second, but I firmly believe that a lot of the challenges we're facing, because we took an approach of a lightweight, low severity airplane, and that allowed us to play with automation. And I'm going to use that term, play. Yeah, when we started off literally playing with automation in our development process, we were able to move pretty quickly in automation. But now the problems we deal with, I believe, are problems that everybody else will deal with as automation increases. Some of the things that I think we see as issues are leading indicators for as the rest of the industry increases automation. And that was because we were able to play with things and move quickly forward. I mean, Zipline folks do a lot of amazing automation too, so I'm sure they have their own perspectives. But yeah, so for me, it was like formulating our arguments, bringing that to the group, and then also finding where there's plenty of great literature and great precedent that is very applicable if applied in the right way. Like we'll play on this later, but I firmly believe like all of the workload analysis, situational awareness stuff is great tools as long as we're measuring the right things as part of that process. So I'll stop there. Sorry.
That's great.
Yeah, I mean, I can go. So I don't have as much experience, 6.5 dozen meetings or so. I got called last week to join, so thanks for allowing me to come in and represent Zipline. But I just on behalf of the team, that they're really appreciative of being able to be a partner with you all to share what we've done globally and what we're doing in the US. So anything that we can do to help drive research, to help drive policy, like we're willing to support. I think it's just really interesting listening like the last day and a half on like the work that's being done and how we can implement that. So just from like the start of training, I think the end number doesn't really matter. Like what we've talked about is how do we keep people engaged in the role that they're doing? How can we apply that just from day one of a new hire and bringing them into the operations and saying, this is your role, this is what you're going to do. You have a lot of responsibility, but you need to be able to maintain situational awareness, not get bored. And I think we've come a long way just with the last couple of years operating in the US. As I was talking yesterday, some people, we used to do one aircraft, took us 9 visual observers to go from our nest location to the hospital we were delivering at under Part 107. Like the amount of progress that we made in the last 4 years, it might not seem like a lot, but we've come a long way from manually deconflicting the airspace, being able to talk to 9 VOs with one RPIC. Apologies for that. Got to get better with the terminology. Yeah, it's just come a long way, and we're willing to continue supporting you all and have you out to see what's going on next. So really appreciate the involvement.
Yeah, and echoing a lot of what was already said, for me, it's been connecting with industry researchers, industry partners, potentially regulators, and that are all kind of working towards similar goals and identifying common problems, and then hopefully influencing all of your expertise to kind of tackle those common problems.
I really see after these meetings, I see our researchers at NASA come back and say, oh, we got a chance to talk with the folks out there flying We see the way they're operating, we see the way that they think about this, and we're re-vectoring. We're moving a little bit. We want to, adjust our assumptions on what those operations are going to look like in things like our HIDLs, in our research efforts, because it's really important to me as a technical lead to make sure we're not out solving some problem that nobody cares about. So the value I'm getting is from you guys. I personally learn a lot from you guys. Can you talk about some of the other value? Looking forward, what is your expectation for this? You flew and you spent your time to come here, and I really appreciate that. There's a value proposition there. Where would you like to see that go in the next few years?
Everybody's looking at me first.
Yeah.
We're in a red shirt.
We'll just start.
Here's an interesting just anecdote is, I think 2 meetings ago, I can't remember which one it was. Lately, all the discussion was about in the future when end-to-end happens. And like it's been interesting. Like I don't hear that terminology anymore in this group. Like because we realize now end-to-end is happening. It actually is going on now, and it's happening every day in the national airspace. So that's good. The reason why I continue to contribute to this group and have visited multiple times is I do think it's an influential voice that can take inputs from a lot of different perspectives and provide clarity and guidance to the regulator to help them formulate how they make decisions. And so my hope for this group is, one, we measure the right things. I want to keep hitting on that all the time. But if we're measuring the right things and we don't just get stuck on N, then leveraging the tools, like the NextLX tools and all of the things we need to do, I think it would give the regulator an ability to say, hey, Wing, we need you to provide this information using these kind of standard processes. At the end of the day, I want to get out of a conversation of just about how many airplanes is the right number of airplanes. I want to get to a conversation about what's driving your workload and what is the proper scope of operations that's acceptable for that workload. How do we ensure safety based on workload, not based on just purely the number of aircraft as the metric? So I'm hoping to continue to engage and still push for that measure what matters kind of mentality, and have that hopefully message go to the regulator as part of this respected group. At the same time, also, I want to keep learning for our team. We are already starting to implement more like workload type assessment work into our activities because of some of the things we've seen here, and that's helpful. So.
Yeah, similarly, let's crank out those white papers, engage with the regulator, and I guess my sky vision is to hopefully forge a pathway for certification of these types of operations.
Yeah, nothing too much else to add there. Just what work can you all do that can speed up the regulations, but also doing it safely? Like use us as a resource. We're able to, if there's anything that we can do in our operations or have you shadow our operations, we're willing to do that. There's not too much that's a secret. Everyone's probably seen most of all of it, if not everything already. So yeah, we're open. We're willing to help you do what you need to accomplish.
Can I just add one concern as well?
Absolutely.
Probably positive concern. My own concern is I still see, like in our white papers, our vignettes and stuff, still imply a certain level or type of automation. And I think we just really need to consider, as we go through the review process and finalization process of those, making sure they do allow for different approaches based on, especially what you've seen in our operation. I mean, like, we do not, I think most of the vignettes still rely on a tactical engagement level with a single vehicle, and we'd like to see, make sure other approaches are considered. So that's one concern.
Yeah, I think that's really important. Just a moment ago, for the first question, we started talking about progress, and one way that I also want to measure progress is the level of the conversations that we have, right? I think from the first time I came to one of these groups, working groups, it was all about identifying gaps per use case, and now we're talking about specific barriers where the level of conversation continues to go up. And we're really I feel that we're fine tuning some of the vocabulary that we're using now, and we're arriving at a great spot. And I think that measuring the right thing, we're certainly a lot further than we were.
Yeah, I mean, sorry, I don't mean to dominate this, but think about interventions and exceptions. There's a lot of different types of interventions and exceptions. And for us, an exception is not going to be going and dealing retasking an airplane. It's going to be dealing with this area-based type of control. And so still it's very relevant. I think the topic is fantastic. Like one exception is always an interesting conversation to have. I have to make sure we don't end up with assumptions that constrain what goes out of the recommendation down the road.
Completely agree.
Can I jump in here real quick? We had hoped to have vignettes or some, little scenarios that identify that were representative of what people are doing. So one might be the one that's in there that, they're in controlling vehicles. Another one might be more what you guys are doing. And I think there's still time, if we wanted to write a short vignette on that and then look at how the metrics that we're proposing apply to that situation as well. And I think that would help show that these are generalizable metrics that work, regardless of CONOP. So maybe we should talk about that a little bit at some point.
Yeah, I know when we were talking through the vignettes, like if you have to just pick one CONOP and one way of operating, you're not going to be able to consider everybody.
Yeah.
And everybody's going to have a very different approach. And I think it makes sense to me to have, different degrees of automation or different approaches. We'll never capture everybody's approach.
Right.
But I think the bottom line, which I think you're spot on, is the metrics and the way you analyze this is applicable no matter what, if you are considering the right factors to drive those things.
That's the goal.
Yes.
We got to see the operations center yesterday, and one thing that I think we got to be clear, I lead autonomous systems, and I'm very focused on autonomy, but we have to remember there's always going to be a human a part of this. And so I want to ask, as you build up operations knowledge, how are the humans in their position? How are they doing? Are they achieving the goals that you set up for them? Have you learned some things that were not unexpected? And to that end, what kind of human factors research are you carrying out based on what you learned with these operations?
So talk about the operations center, so I'll jump in, but I'll definitely much for you guys to jump over. Let's see. One critical thought, just from my perspective, always is like there's always the citation of like 80% of accidents are caused by human error. I think there's a Langley paper that came out a few years ago, which I find fascinating about the human contributions to safety, but we don't talk about how many times the human saves things. And I truly believe the value of the human is extraordinary, and we should approach our designs with like, how do I leverage the human the most, not how do I eliminate the human the most. Like take as much as I can.
Yeah.
I'm not in control of all our designs, so that. But so I do believe in this fact that like I don't want to eliminate our pilots. I want to make our pilots capable of doing more and more and more, supervisors or whatever they're called and become. Right now, what we are doing is like when we make a major change, we do a workload assessment. We do a case study with them and evaluate their there's qualitative and quantitative tasks, and I'm not going to get into all of it. A lot of it's based on some of the NASA work. And how deep we go with that depends on how big the change is. And if it's a small change, we're probably not going to do a full massive study. But I think where we're ending up right now, our operators, our pilots, our supervisors are still engaged quite a good bit because of this traffic deconfliction task that still exists. There is a good question that happens of when that task goes away, because right now they're having to look at a lot of airspace, and there's a lot going on with that makes them stay alert and pretty well engaged with it. When that one goes away, then there becomes a different question about are we leveraging their skill set the most. My hope is we'll be able to work with the regulator to expand scope so that they're still dealing with enough that's keeping them engaged. But the underloading is a real risk. I mean, it is a real risk, and I think it's one we want to continue to address. I don't know, I think I could probably ramble and not say anything for the next 5 minutes. I think we do leverage the human quite a bit, and especially I think Chris brought it up a couple times yesterday. Chris Jackman, our certification lead. Right now, what's actually perhaps more throttling is the human-to-human engagement, not human to system. Like we're having to coordinate across a lot of different people on the ground. You heard VOs and and just doing daily briefs and debriefs at the end of the day. And there's a lot of engagement between people to people, especially at a scaled operation. I think that's actually where we need to do the most improvement long term is how, and we get so focused on the system, but when you look at a big scale operation, it's sometimes not the system that drives the challenges, it's actually the people. Sorry, I'm rambling, so I'll stop.
I think that, I don't know that 5 years ago we would have thought of the workload, like not having enough to do as a problem.
I guess similarly, in our case, we're ArcGIS operating in the NAS, and it is that human-to-human element. In our case, ARPIC to ATC, voice communication that not only keeps them engaged, but also is kind of a limiting factor for scaling to end-to-end for us. So similarly with your human-to-human element needing maybe improvement is kind of the same focus for us. But we also have VOs in some cases. Scenario-wise, we're focusing on some of the unique cases for our UIS. So latency and voice communication, lost link procedures, and then also DAA. So some of the more unique things for our ConOps, that's been a focus for our human integration work. But I'm trying to think what else. We're working with one of our former interns that's wrapping up a master's at Oregon State is doing some fun research on multi-channel monitoring, so diurnal listening, that hopefully will become applicable and help us scale to end-to-end as well.
I think we've been able to cut down a lot of the communication, just talking about like human-to-human aspect. Like when we first started, it was you had to get permission to do everything. You had to get would say like, we're ready for launch. Okay, like now can I launch? And it was just a lot of back and forth. And that was good when we were doing 1-to-1, but then 1-to-3, 1-to-6, like it just showed like we needed to cut back communication and trust the automation. A highly automated system, it's going to alert us when we need to be alerted, but we don't need to just have all that extra communication. Like when the zip's coming in to recover, we used to say like the recovery area is clear and ready, but like that's part of their job. They're already going to check that. So why do we need to communicate it? And just proving and validating that we can do that with the regulator, showing how it's safe and still the same operations. It's no different. I think another big thing that we're trying to do to like help the human do their job is simulate a lot of this. We talked with some of the people yesterday, but just getting approvals through the training program. Like we don't need to fly. Someone doesn't need to fly 20 actual flights to get certified to be in our operations. Just we can provide a lot more real world experience. Today we just replay scenarios that we've actually gone through, but being able to get approvals to just simulate what the our PICs need to do to be able to get certified to do their job. We can interject a lot more in a simulated environment than just sending, I don't know, 20 different flights, or even with our visual observers to get signed off. Like we still have evaluators that have to go out and make sure that they observe X amount of flights to get certified. Like, why couldn't it be a time-based thing, or why couldn't it be a simulated thing?
It's excellent. I think that the internal buildup of institutional knowledge and cycling it back into simulation and to training is what I'd like to see. Hopefully there are opportunities also for potentially this group to collect lessons learned and be an aggregator of sorts in the future. Maybe before I bring on more questions, I open it to the group if there are other questions. Yes.
In the past, Reliable has presented some studies you guys have done. You know, there were studies that were more generalizable type studies that wasn't just about necessarily your design, but there were studies in general. In particular, they were looking at step-ons and communications issues, and those were good studies. Are you doing internally studies like that that might be potentially shared with the community, this community or the larger community, to add insights in addition to the insights? You know, I work at NASA. Our studies are excellent. We add a lot of value to the community. Great. But also studies that you are doing that could add value to the community.
Yeah, certainly the voice buffering solution that we hope to publish. We're still waiting on patent stuff to get through, and would love to share all that with you. Trying to think what else. Most things are kind of in the white paper stage right now, but we hope to share those, with you. I can't think of any particular like human in the loop testing that we're doing right now that might be generalizable, but I have to think about that one.
One question I have to, Andy's done a lot of work on accountability, and as we get higher and higher levels of automation, it becomes a real issue and a real question about who's accountable. If something does go wrong, I know we don't want to think about that, but in worst case, something does go wrong. Do you think about this? Do you know who is the belly button that's in charge there? Do we still think that the supervisors that have these high levels of automation, they're not even in the wing case, not even monitoring the individual aircraft, but someone has to be, on the hook kind of thing. Is that on your radar? Do you think about that in that kind of concrete way at all?
Yes. It's a lot of what spurred, honestly, the paper that we wrote at ASTM. Andy and I were both part of that, about operational control, what happens with automation.
Let's be clear. Mark led it. I was part of it.
I don't know if I led it. You probably put more words on paper than I put on the paper. Anyway, so yes, definitely very passionate about this topic. And honestly, I'm almost as excited about what Part 108 says on this as I am about all the other things that are in Part 108. Everybody asks what's the most, at least from what's been shared to us as ASTM and listening sessions, it sounds like there's a move towards an organizational responsibility away from individual responsibility and accountability. I don't want to get into definitions of responsibility and accountability because I can't remember them. And it's actually one real challenge for our pilots coming in. It's like, if you're a traditional pilot coming from a crewed aircraft, yes, I'm responsible for every move that aircraft makes, everything it does throughout the entire flight. I have no authority, no ability to do that in our system at all. So I don't want our pilots to feel like, oh gosh, their airplane didn't fly the way it should. It's their fault. They are the ones responsible for it. The challenge is the wording that's in the regulation now versus the actual in practice of, yes, the system designed by engineers. Our head of flight automation likes to say we're moving more of the pilot into the engineering development cycle, and we're, as engineers, having to wear pilot hats more because we're controlling the operation, or not controlling the operation, it's the wrong word. We are, the behavior of the aircraft is driven by what we do on the engineering side. I don't have the answer to all this. My hope and my goal is that the accountable person, yes, we do know who is responsible for each function of that system, and that person will eventually be the one regulator in an enforcement action would hold responsible as well. We don't have, I don't think, proof cases today to see how that would play out yet. And we're willing, we don't have that for us.
Yeah, I think with a lot of people who do come from traditional aviation, they're like, oh, my certificate's on the line.
Yes,
like they're gonna come after my certificate and I won't have a job anymore. And like we like to just make sure that we train that, like, as long as you're operating to the approved procedures and the training program that we have, like, you're not going to get in trouble. Like, it's going to go back to that responsible person, like the director of operations, whoever that might be. But yeah, it's like the engineering mindset is probably a lot of the companies out there didn't have traditional aviators in their engineering department. So being able to just kind of like keep sharing that message and they're like, it's not traditional aviation, but you still have to have that same mindset of how the airspace works and how to integrate safely. So being able to just educate, like, these are different classes of airspace. This is why we can't fly right next to an airport or right at the approach or departure end of an airport. Maybe one day we can, but like right now we can't. There's really a lot of education internally too. And yeah, that's a big part of it.
Yeah, so that sounds like the evolution of a aviation culture to include team mentality, right?
Definitely.
Great. Any other questions?
So, following what Justin mentioned, from a workforce development perspective, during your hiring process, when you see the people you hire, what special skills, expertise you expect for the college students, graduate students, you want them to have, but they don't have currently, so that we as educators, we can prepare them well for the future.
Yeah, that's a great question. I think as the operations evolve, we're not going to rely so much on having a big flight operations team. It's going to be more of a maintenance team and an engineering team. But we do have a couple pipeline partnership programs right now, one with Embry-Riddle, one with USI, Manned Safety Institute, and one with North Carolina DPI. And so they have those three different pathways have different requirements. Like if, for example, the North Carolina one, if the students go through the approved North Carolina program, they have recommendations from their teachers and they get a certain grade in some of the different courses. They're not a guaranteed job, but it's a guaranteed interview, similar to how airlines do that with some of their pipeline programs. So that's a way that we can get interest and get good talent that we want to have. But when it comes down to it, they're going to need Part 107 license. Right now, they need a third class medical. Maybe that won't be a requirement anymore in the future, but that's what it is today. And so beyond that, like we're going to train them to how we want them to operate. And one of the big things we look is for decision making. You can't really, you can teach that, but it's really, we put them through a lot of scenarios, and like part of the interview process is, well, how would you handle these situations? And that's a really big part of our training too and evaluations before we sign someone off. It's not like, how do you manually fly an aircraft? Because we don't do that. It's really about how can you handle this workload and making the right decision.
So he stole my talking points, which is great. It sounds like we're very aligned in the way we do. We don't have the pipeline set up as described, but just in general, we expect everyone to have a very strong working knowledge of the airspace and aviation operations. Like that's like a baseline. Everybody has to have that. If you're a Part 107 pick that has that knowledge, great. If you're a 10,000 hour commercial pilot, great. We do have a 10,000 hour commercial pilot, I think, in our team as well, which is kind of crazy. They come from all backgrounds, but let's just assume that. The very next most important thing is what Josh mentioned about decision making. They have to go make good, sound decisions, and that's how they're evaluated in the onboarding process. And then as they go through their training program, our 135 training program is very specific to our operation. It's not like anybody's going to come out of the industry with knowledge of how to operate the wing system. We don't sell the product out externally, so we're going to teach them how to fly it, show them they need to make good decisions. And it's honestly where people struggle the most is when they are not able to make either timely or effective decisions. That's the biggest challenge they run into.
Those scenarios that you guys use to test their decision making would be very interesting to this group if it was possible that you could share some of that, and for us to understand what kind of decisions that you think are critical to the folks that you're bringing in. So it's something to think about in the future if that's possible.
Yeah, I always focus on decisions in my background, either decision support systems or systems to provide all the information necessary to make the best decision, for the human in the best situation to make a good decision.
Mm-hmm.
Yeah, I think, okay, we got a couple here. Go ahead.
Related to that, a lot of you described going to the pilot pool for potential recruits, whether it be 107 or a 10,000 hour commercial pilot, which
It was a capture on an A380, which is crazy.
Right. Have you thought at all of looking at other aviation licensed personnel like dispatchers and or controllers who have kind of a different perspective on the, they have the aviation safety culture, they have those decision-making skills, but they have a different background in how they view flight operations. They have a more systems view of flight operations, in particular the dispatcher community, because, when I watched, the operations and my familiarity with the operations that you guys also have, much more like a dispatcher than a pilot.
It's a good point, and we have not pursued that pipeline yet. I mean, it would be an interesting one to do. It doesn't like we're not short on supply of applications. At the same time, it might be we can get some really good decision makers out of that, thinkers out of that group, so it would be worthwhile.
And one of Reliable's definitely engaged with air traffic controllers as well in terms of end-to-end style operations. It looks very analogous to what an air traffic controller might see. So their experience with managing types of operations, interfaces, et cetera, has been invaluable for Reliable.
One of our new hires, he came from like a medevac dispatch unit, so he knows the dispatch world. He knows low-level weather really well. That's really good to have, and I think early on in operations, that's great. But yeah, I think as we expand, I wouldn't want to look to see to add more requirements for an operator or controller to have. RPIC, I'm sorry. So yeah, I wouldn't want to add more certifications they need, because in the end, like if it's a pipeline program or if it's like truly scaled operations, like why would they need that?
Well, a dispatcher license, that's tied to 121 operations. There's a lot of knowledge requirements associated with 121 that won't be applied to, and I'm not suggesting they be a licensed dispatcher, but just, looking at that community for a different skill set.
Yeah, I think like the way our operations are set up, I think like maybe what we call a flight ops manager, someone who would oversee all of the RPICs, they would have an additional level of training and certification, which would be really valuable. But yeah, I think there's definitely opportunities there for that. So yeah, we're not going to turn someone away who has that. It's just an extra skill set. But I know at the dispatcher world and our operations are a little similar but different. So yeah, definitely a good point.
Hasni, and then we'll move over.
Could you speak to how you balance the near-term needs versus long-term, both from your perspective and the industry? And for example, end-to-end is already there for the small, it's probably further out, etc. And how do you see the role of academia and research centers helping you manage that? So internally you have to balance it, but we want to help you get off the ground. At the same time, we want to make sure we're scalable. Right? And end-to-end is very much in need of scalability. Usually the shorter requirements of that. How do you do it internally, and what do you see our role in research centers helping the industry in that balance between getting off the ground near term versus scalability?
I think, like you mentioned, I guess in our case, it's proportional to near-term needs. So, our focus and most of our time is spent on getting to that one-to-one case, and then, but identifying the problems that need to be solved in order to eventually scale to end-to-end. And I think that's where this forum and you all have assisted and come into play to kind of start tackling those problems. But yeah, I'd say most of our effort is not spent on end-to-end at this point, besides problem identification and potentially a plan to solve said problem.
Right now, it's again focused on what we're doing. We'll be launching in the DFW Metro here in the next few months, so really scaling that operations up. I think when it comes to universities and different institutions is just talking about the different use cases of UAS. I recently moved to Illinois, and there's a local community college that has a UAS program, but nowhere in their curriculum do they talk about package delivery or any other types of UAS. It's all agriculture, because that's in the middle of Illinois. There's not much else out there besides agriculture. So just being able to share the different use cases and what companies are doing today and some of the plans for the future.
I would say that we are nowhere near the end state we want to be at. I mean, if there's one thing that's true, we will continue to adapt and evolve and change. One of the things that we do a lot of internally is, I think it's debate about what is the future end state look like? What is the right end state for our operation? And there's a lot of discussions that are always on. This is like a nonstop. Like, we're always talking about this. What is 2 years from now, 5 years from now look like? What is our ultimate goal? And I think we're crystallizing on that. There's an interesting concept of what does this look like at truly global scale? It doesn't look like what it looks like today. It's like the one thing I can tell you for sure. And I know what it doesn't look like. Now the question is, what does it look like exactly? What I am really interested in is, like, can we, if we have a vision for what that future looks like, how can we get validation that that is the right kind of goal setting? And I don't know, like, I can't commit our company to say that we're gonna come to NASA to review this kind of concept and prove it. But I think there's some good dialogue that can happen when, as we move into future states or we're future planning what we want to do and what it might look like, to have other parties evaluate that as well. We have had researchers come in and do studies of our current operations and assessing how workload and other activities with our current systems look like. It'd be interesting to do that in a more forward-looking state down the road. But yeah, we're not done, so there's plenty of more work and engagement to come, I think.
Well put. I think that it's a great time to start looking forward and do some visioning, and maybe we know. For me, it's a little hard for us in our laboratories to think about at scale. You're going to learn things while you start to scale, and for us, those are very hard to see. And this back and forth that we're having between us on scalability, on personnel development, and bringing some of our professors in, and on the type of certifications and what you're looking for in your operators, your RFICs. I think that this is a big need, and that hopefully the group can continue to fill for many years. Kara, I know you had one.
Yeah, I was just throughout the last couple of days been thinking, because I'm an organizational psychologist, right? So I think a lot about, like, what people's jobs are. And it seems like the use case or how these things are being deployed really changes. Like, there's a lot more variability in what the remote pilot's job is or might be. And do you guys incorporate, like, job analysis or task analysis before you do your training? And how are you going to handle kind of those changes and what that job is over time? Are you anticipating they're kind of going to stay the same? Like, you'll stick, like, that person's job will look very similar as it does today in the future? There's a lot of questions in there.
We absolutely do task analyses for different for our operator, for the RPIC, for the interface, for autonomy, what functions, or functional allocation analysis as well, and then identifying sort of what new tasks exist or stem from these types of operations as well. Things like handovers were commonly mentioned over the last couple of days. This is a new task or a shift type mentality or phase of flight. So yeah, we definitely are considering or run task analyses and leverage that to form better interfaces, what to test, what to train on. That's kind of the foundation of lot of products that we build from our task forces.
Yeah, I mean, any change we would implement, like since our 135 carrier, all of our training program is approved by the FAA. So any changes to the job or how we train, that would have to get approved. So it's not like we can just interject a change or immediately change something. Like there's a full process that we have to follow. And then we also have a safety team that will do risk assessments and quantify that as well. So yeah, it's going to change. Like what that looks like, it's to be determined, but there's a lot of thought around that as well.
And similar for us. I mean, yeah, there's a lot of analysis that goes into any change, any procedure change, any down to that level, but also just the role as a whole. Absolutely, the jobs of our operations teams will evolve over the years, and they already have evolved dramatically in the past 5 or 6 years. They look nothing like what it used to look like for them, and I think that will continue to be true. And this is like a very pertinent question, because we are literally asking this question right now. What is that person's job title and role and description going to look like in 2 years from now? Because I do think it'll evolve, and it depends on a lot of different factors. We do try different concepts in a test environment before we get to a full approval, and some of those work, some of those don't work. And we'll see how it plays out. But yeah, it's not static at all, and I think we'll find some things go well and some things don't. There is a mentality a bit in the tech world of like try things and see what works and what doesn't work. As long as we also keep that with the aviation safety of don't implement anything that's not safe. Yeah, bottom line, yes, it will change.
I think like just to add on to that is there's been talks like, well, if someone's staring at a screen for 4 hours, they might get bored or might get tired or might have less situational awareness. So what happens when that person's doing that role for 1 year, 2 years, 3 years, and there might not be any job growth? Like what else is there going to be beyond an RPIC? So that's something that we're thinking about is how can we keep people engaged and committed to the job, and what's next beyond just monitoring the system.
Great. Yeah. Georgia, I'd like to understand what you meant. The last thing you said was about scale. Like I hear scale a lot, and I'm kind of drawing a blank on what that means. I think it means reducing cost per flight or per delivery. Is there a vignette that would demonstrate scale, or how, like, what does scale mean when you say it? I've heard it several times, and I understand that, I get it. I mean, a little bit, but what more does that mean? Like, what is the problem? What is the problem with scale? Why not just more rooms with more operators and just more? I'm not, I don't totally understand the scale problem.
I think that maybe this is a great one for all 4 of us to talk about. When I think about scale, from my point of view, I'm thinking about increasing levels of autonomy to achieve more operations in a more complex airspace in the future.
I'd say, the affordances of increasing autonomy decreases workload and thus can increase the number of simultaneous operations that are being monitored or supervised by an operator. So that's what I guess my mind went to when we're talking about scale. So how do we scale that ratio higher based on the affordances of autonomy? But maybe
But handling the exceptions as well, because the exceptions seem to drive, it's not about N, you want to increase N, but the limit is not N, it's about the exceptions, right? So figuring out how to increase autonomy and address the exceptions that occur, right? So.
Yeah, exactly.
Yeah, and for us, it's true cooperative and non-cooperative DAA. Got to have lots of low-level weather data, good low obstacle data, and then like as operations scale and the N number goes up, that's going to drive costs down. So it's a combination of all of that.
Weather, you mentioned weather. I haven't heard a lot of weather, but there it is, right? So it's important.
And so when talking about scale, I think scale, you hit right on it. I think that it's cost. So economic viability of this. And it's also just resource availability. Like there's not an unlimited number of people that will be good decision makers in this role and pilots and et cetera. Right now, it's not been a problem, but it's not unlimited. But if we had to hire 10,000 pilots, that probably it's gonna be hard to make your delivery to your house effectively cost effective, like something you're willing to pay for. So there's a bunch of different factors in there. But when we think about scale, we think about, I would say, scale of capital letters, like big time, global, millions of deliveries kind of things. When you start looking at problems from that problem set, it's what works in a metro region may not work at a global level.
I think the number of operations, if you're proliferating the sky with drones and UAM vehicles and stuff, then safety becomes paramount. And how do you make it or maintain the levels of safety? That'll drive automation and other procedures or whatever to make sure that the accidents are kept to a minimum or try to, don't let them even exist, but that's not reality. So that's what I think about when I think scale.
And that's a more complex airspace, yeah.
And that's what I think that is again what drove a lot of the way we've developed our systems. I had to do it because it's fun. I watched them last night and it was great. There's 2 videos that came out yesterday on YouTube. One from Adam Savage, the guy that was on Mythbusters, on his tested, and another one from the SOMO guys about they tested our aircraft, dropped it out of the sky, broke it, and showed all that stuff. That whole talk about safety at scale. One of the big advantages you get of a frangible foam airplane is what is the possible severity of outcomes there. That's the first time I know of a video where our airplanes laying in pieces, broken all over the place, is like advertised over YouTube to millions of people, and there's tons and tons of pictures of broken airplanes. With the point of they break on purpose. This is the reason why we designed them that way, such that at scale, that severity risk still stays low. You also have to have reliability on top of that. But now we can help drive those risk numbers low enough that, quite frankly, there's the FAA problem of safety and like what we all think of aviation safety, but as much as that or more is public tolerance to safety issues. Like we were dropping airplanes and causing safety events in the community. I don't think they're going to be very happy about it, regardless of even if the FAA and NASA and everybody says it's okay. The numbers are all good. The community won't tolerate it. Yeah.
Other thoughts? I think we've got maybe time for one more.
Sure.
Yeah, if you would, I think you got another. Yeah, go for it, buddy.
If they had to make a decision to move forward, because on the PA side of it, things were not coming fast enough. From your perspective, the industry, are you sometimes having to make decisions to go ahead and automate things and for the figure? Then sometimes about the human factor and safety, you go automate too fast. Would you say the human factors research and safety research support your decisions fast enough? Or do you feel like you wish for this community to be having you do more of this and to be doing more?
I don't know if I caught all the end of that question or not. So could you summarize just like in one quick?
Well, so I see this community as bringing human factors, safety. It's actually really much from the human factor communication, safety analysis. Then there's the operational side, engineering side. You guys, you have to make decisions to how much to automate, how much not to automate. Sometimes these decisions need research and support. And I was on a panel, for example, at DASC, thinking, discussing whether the human factors community is keeping up and whether the human factor is taken into account sufficiently in the decisions to automate. And this is an area where we're automating a lot. So do you feel the same? Do you feel like you're forging ahead and leaving the human factors in the safety community sort of trailing behind, or are we doing enough to guide? Or maybe that's Any thoughts on that?
I'll give you my opinion, which is not a company opinion. But my opinion, like we have, there's an expectation of moving at a speed at which is faster than like doing an external collaboration and diligence that would entail of that external collaboration is going to be able to facilitate. So that's all going to happen. It's going to, it had the cycles of development happen internally at a speed unlike anything I've ever seen before coming to my company, which is it's amazing. That said, you know, those do play into that. There is that loop that should we be automating this thing or not automating this thing? If we do automate this thing, what does it do to the human role and how does it change it? That's all happening and very dynamically. And a lot of times with because of our simulation capabilities and all, we can test that in real time as we're actually changing things in a development environment. So I think I guess my response, which may not be satisfactory, is I think that does happen. It happens more internally to the company. And the good work going on externally about human factors research we'll rob and steal as much of that as we can and pull it internally. But I don't know that we would have, there's not an ability for us to do an external collaboration for everything we're changing. It's just the cycle would be way too slow.
Yeah, I mean, the company is always wanting to move faster than where we're at today, but how can we still do it safely? And that's one thing we have been able to do internationally is being able to deploy software faster. It might not have to go through the same change process and approvals that we have in the US. So we still have our same levels of safety, but we can get software out quicker to the field, get feedback on that before we roll it out to maybe a US location. So being able to iterate quicker is something the company's always focused on. So yeah, but still maintaining the same level of safety.
Yeah, I think the research that's produced, there's always a necessary next step where what is tested and published is going to be fundamentally different than what our specific design is or operations, and we have to prove that case out because it isn't exactly like the paper. So there's always additional work on top of whatever research is produced, however rigorous it is. So sometimes that the research that's produced is a good first, second, or even 10th step, and helps guide our design. But eventually, that the burden still lies on us to test and prove that our specific system and our specific operations are safe. So with that in mind, I love all of the research that's been produced because that's accelerated our design process, helped us start at a good spot versus exploring the big design space. So continue to do that, but know that we'll have to kind of do our own specific testing and proving out that our system is safe and viable on top of whatever research is.
It's great. I think HASB is looking for ways we can continue to be impactful with our research. And I really thank you guys for helping us close in on some of the assumptions that we make in our research. Simultaneously, we learn from you how quickly things are evolving, and we try to keep up. Yeah.
Great. Thanks, guys.
Yeah, I want to thank all of you.
So we're going to take like 15 minutes, come back at 11:20, and we'll have the
Great.
Yeah. I know that Mark has yes, at this point, but I wanted to really thank you for the demos that you put together. I think it's impossible to overstate how important it is to government and academic researchers to see what's going on in the world and understand it a lot better. So it was really helpful, and we appreciate it.
Awesome. Glad to have you all out.
Okay.
Share, which is where do we want this group to go? And so what we've done today is obviously we heard from industry. Now we're going to hear on the government side. I have some great panelists here today. They're going to give a little bit of information about what they're working on. I know some of us know some stuff about what they're working on, but I don't think all of us know everything about what they're working on. And so it'd be great to get some insights for a few minutes on what is exciting to them, what are they passionate about, And then I had some questions about where, as a group, we think we want to go, how we want to evolve, just like we evolved from our 4 working groups years ago to where we are today and coming up with this white paper. Where do we go next? And so what I want to do.
We're taking a break.
Nope. You wish. All right, panelist introductions. So we have 5 panelists. First one is Tim Bigelow. As we know, FAA, he so graciously hosted us this week. Quick background about Tim. Prior to the FAA, I didn't even know this, he was a flight instructor and a charter pilot. He worked with UAS certification for Part 135, that I did know. Today he's part of AFS 700 and is a national specialist for UAS carrier operations. Next is George Gorospe from NASA. He's a senior research engineer with the Intelligent Systems Division at NASA Ames. He conducts and presents research in the fields of diagnostics, prognostics, hardware accelerated computing, autonomy, and automated test systems. He also drives the development of new technology within the application areas of robotics, aeronautics, and space exploration. He also serves as technical lead for a variety of autonomous programs. Next is Andy Letcher. He's the chief technologist for future airspace operation at NASA's Langley Research Center, working on the safe operational integration of new aviation technologies. He's a subject matter expert on the safe and secure operation of uncrewed and autonomous systems. Previously, he worked at MITRE and Boeing. He tells pretty good dad jokes also. Next is Jordan Sakakini from NASA. He's an aerospace engineer in the Aerospace High Density Operations branch of the Aviation Systems Division at NASA Ames. He's currently the lead for contingency management, concept architecture, and collaboration within the German Aerospace Center, DLR, and the Pathfinding for Airspace with Autonomous Vehicles PAV subproject, which is under air traffic management exploration. And last but not least, we have Summer Brandt, also from NASA, part of the system-wide safety project under the Airspace Operations and Safety Program. Is the co-lead of the Human Autonomy Teaming Lab, the Human Systems Integration Division at NASA Ames. Actually, I probably should have shown these inside. So the challenge. So as we've seen over the past 2 days, this group continues to accomplish some really cool stuff. It's awesome that we have academia, we have industry, we have government all working together, looking at how can we best work on AAM, UTM, UAS, NAS, the whole M10 concept. We also recognize, and just like last year around this time, what's next? So we've accomplished a lot of great things. Where should this group go next? How should we best serve the communities that we work within? And that's something that I hope we can talk about in the next hour today. So as you consider where this working group can go, the panelists are going to talk about what's passionate to them, and we're going to circle back with questions. I have a couple questions leading into it, and then I'm going to open up to the audience, and there's 1 or 2 questions I'm going to finish up with today. So first off, what I want to do is I want to invite Tim to the stage and give a presentation of the stage. You can sit there if you want, you can come up, but talk a little about what you're passionate about, what you're working on. Just a few minutes.
Passionate about UAS, first and foremost. I started flying RC back in high school, and I've just loved UAS and everything where it's going. Projects that we are working on and what we're moving forward to. We now have our first operator that's been certified to use simulation for training and checking of their remote pilots. Used to be up until just literally a month ago, all of our operators have to use live flights to go out when they're doing their training and checking. We want to get away from that because the problem with live flights is if those that have actually flown before in real airplanes, that you simulate something, you just cover up. You can't see your altimeter now, or if you got weather moving, hey, you got weather moving in, and that's all they can do. But with simulation, it's train as you check, train as you fly as you train. I'm a big believer in that. I was also a training center program manager in the past, so I dealt with flight safety and all the training we did, everything from Citations, Gulfstreams, and larger airliners. The point is that we want to be able to use simulation that can train real world. So the computer should be laid out exactly the same. The size of the monitors need to be the same. We don't want to use small monitors trying to look at versus something they'd use a large one. we're looking at, when we started doing this, we started looking at how they're laying their monitors out. That was an eye opener for us. You know, where their map is of the aircraft they see, their maps that they have open for how they communicate with their other personnel, the charts they have open that displays each aircraft and what each aircraft is doing or what stage it's at, any type of annunciator systems that they have applied on there. So we started looking at this in detail, and we realized that, hey, we need to start, we have no standardization for cockpits. So this is something I'm hoping NASA will get more into, is giving us feedback on what should be a good standardization for the remote center. And so going through and doing the certification of it, it's not like a regular simulator. There's no motion, no visuals. You're just using a computer bank at home, so it can easily be done. So this is why I'm passionate about the training, to see how we're going to get the remote pilots, and that's what we're calling them for now, until we come up with a new name based on what system they're flying. And it may be different names. You might have one name flying certain type of aircraft, and another name flying for other aircraft. And we are working on that as well, as we write things. 108, but it does come out for publication. I am one of the writers on it. I ask everyone to take the time to read 108 detail from beginning to end. And if you get a chance, read the preamble, and you'll understand why we went in certain directions compared to what we've been doing up till now. And hoping it's supposed to be published after the first of the year, but with a presidential election year, that means things can change dramatically, and they could put holds on or pull regulations completely from the registry. So we don't know when it truly will be published. We're just hoping sooner than later. Those are the big things I'm passionate about: is UAS, many to one, and where we're going simulation. I know I keep going.
Awesome. Actually, we're going to come around this way. We'll end with Summer because she has a couple of slides that will then go into the questions. So next is George.
I've been at NASA for about 10 years. In the last 2 years, I've got a chance to take on a new role at NASA as the technical lead for the autonomous systems discipline. The autonomous systems discipline is slightly different from a mission or a project, in that it's NASA's year-over-year investment in autonomy capabilities and technologies until we run out of money or we solve all the problems. And so to that end, I get to focus on barriers to achieving more autonomy in the airspace. And we focus in 3 separate areas. Barriers for autonomy on board the vehicle, barriers to autonomy at the human autonomy teaming level, how can autonomy help the human, and then autonomy in the airspace, whether or not that's infrastructure or means for scheduling, planning, deconfliction, things like that. Additionally, what we've been able to see a little bit of this week is that there are a number of activities within the autonomous systems discipline. The end-to-end working group is one of those activities, and so I get to advocate for the combined this outreach with industry and academia, because what I think is super important to me, and I'm very fortunate to have this role at NASA, is that I don't want NASA to go and solve some problem that only NASA thinks is important. I want to spool up people and time and resources only to be out of touch. So I really rely on this forum to revector both myself, my thoughts, maybe some of my definitions of certain words, and to allow me to provide technical guidance for the activities that I manage, whether or not that's the human autonomy teaming research that was presented from Garrett and Mike and Eric, some distributed sensing work that we do, some contingency management work we do, as well as some seedling efforts as we start to think about what's going to happen in the next few years after 5 years from now, 10 years from now, 15 years from now. I have to try and predict what problems are significantly out there, to the point where groups like Reliable, or like WISC, they're thinking about getting in the air today, solving those problems to get in the air today. And I think our part within autonomous systems is to look at what problems don't they have time to think about it? How can we get that ball rolling today so that when they do have time to think about it, they don't have to decide from 30 solution paths. Some of them are, of course, not going to be viable. We've eliminated some of the very clearly in, poor paths and already identified good paths for the technology to go.
Thank you, George. Thanks, Andy.
Well, this is gonna sound a little hokey, but what am I passionate about? The future of aviation and having the ability to have an influence on that future of aviation. And I've been fortunate in my career that I've been part of several different, what I consider significant paradigm changes in aviation. I was part of a paradigm change that many of you probably don't know about called collaborative decision-making, where we shifted how we do traffic flow management in the air traffic management system to actually involve the operational users of the air traffic management system in a more collaborative fashion. I was involved with NextGen, was part of the team that wrote the original NextGen plan at the JPDO. And I was also part of a paradigm change associated with unmanned aircraft. And I've done this working mostly from the FAA and DoD perspectives. The unmanned aircraft, one major paradigm change that I was personally involved with was the whole small UAS rule, helping start the rulemaking process, involved with the whole rulemaking committee and the rulemaking team inside the FAA. And so I got to watch that process, and that paradigm changes don't happen overnight. The CDM process took about 10 years. The JPDO, a little longer. The small UAS rule, most of you probably don't even realize this, but it took 9 years for the small UAS rule to go from a concept to a final rule. And paradigm changes like the one we're talking about, end to end, are huge. And being involved with it, and being involved with paradigm changes requires passion, but it also requires patience. And the two go, in order to make, oh boy, 3 Ps. In order to make a paradigm change, you need that passion. And I think this room is full of people with passion. We need patience to do it correctly, and we will make it happen. And one of the reasons I came to NASA was I saw that as the best opportunity to have an influence on that paradigm change, rather than go to a single OEM to apply that passion there. And so I'm excited about this future. I'm glad this community is working together, and we'll get there.
Great, thank you. Next to Jordan.
All right. First of all, I'm glad to be here. My passion, I would say, is using aviation, especially increasingly autonomous aviation, to help people around the country and around the world. There are lots of communities around the country and around the world that are really quite inaccessible. And so they have lack of medical resources, lack of fresh food, so on and so forth. And so within PAVE, the Pathfinding for Airspace Autonomous Vehicles subproject, one of our goals is to integrate these increasingly autonomous vehicles into the airspace as they exist today. So can we take say a Cessna 208 or an eVTOL and fly it from a conventional airport to maybe an underutilized non-towered airport that's out a 3-hour drive, say west of here? I live in Texas. I've driven to West Texas. There's not a lot out there. It would be really nice to be able to fly out that way and help to improve lives for people out there. I want to put on my other hat here. So I'm here representing PAVE, but PAVE is a sub-project of Air Traffic Management Exploration Project. You might have seen Shivanshali Sharma was originally scheduled to be on the panel. She's our project manager. I'm substituting in for her. So ATMX has a bit broader view. They really span through the 4 different sub-projects, the very current day with the Digital Information Platform, or DIP project, out to significantly far future with the next sub-project that's looking at integrating, this explorative XDM across multiple different layers of airspace. Where PAVE fits in is somewhere in the middle. So we're looking at integrating large UAS, fixed wing and eVTOL into current operations. So the assumption here is we're flying under IFR rules, at least to start. And starting off potentially one-to-one at conventional airports. But if you then go talk to, say, the Regional Air Cargo Carriers Association, the people who fly regional air cargo, who would fly passengers on commuter airlines, things like that, they will tell you that the business case doesn't make sense if you cannot scale it to end to end. And so, yes, our focus is one-to-one initially to get that entry into service, but we also have to have an eye out for that future end-to-end operation that we want to move to very quickly. So that brings up a lot of course, different issues. And I think that where we slot in nicely is this integration with the NAS as it exists today. So we're not below 400 feet, more or less segregated from everybody. They're flying in, especially at non-towered airports, with cooperative, non-cooperative VFR, there's IFR aircraft, so on and so forth. So it opens up a host of a lot of problems that increasing autonomy can hopefully help to solve. And by increasing the autonomy in this way, this will then hopefully be able to be used for other end-to-end operations as well.
Great. And lastly, but not least, Summer, and you want to control the slides, or you want me to hit them?
I can just tell you just the first slide first. Okay, so I took a little different tactic of including some slides because I don't know how familiar this group is with the System-Wide Safety Project at NASA, and I have a few different hats that I wear. One being the co-lead of the Human Autonomy Teaming Lab, which Jay previously led, which Garrett leads the T-Cubed work out of. So I'm really personally focused on the human component in all of this. And then I also have work that my group leads on system-wide safety. But where I'm really sitting here today is to talk about the project at a high level as the deputy project manager for system-wide safety. So we have two threads of work, primary threads of work. It's operational safety and design safety. Operational safety being where we're looking at advanced safety management system concepts. So we're looking at tailorable safety management capabilities that would enable applications for, safety management applications for specific operational contexts. And then for design safety, that's the focus is on assurance of autonomy. And so that's the AI ML applications and a means for coming up with safety cases necessary to enable future concepts, all types of future concepts down the road. We bring these together in our operational evaluations. We thread them together. And the focus there is being able to develop an in-time aviation safety management system. And when I say in time, I'm talking about more data-driven, proactive and predictive safety management systems than we currently have in place today. And so what we have a project called a sub-project called the Safety Demonstrator Series that really knits these together, looking at entrant future operations. And the goal of that work is really to be able to provide recommendations for the requirements and standards that are necessary to monitor, assess, mitigate risk in these different type of operations. And we're focused in disaster-oriented operations. Okay, so now we'll actually go, I do have two interesting slides. So next slide. So this is the safety demonstrator scheduled progression. And we selected 4 different types of operational use cases Currently, we are working the hurricane relief and recovery use case. And we selected these because it provided us an opportunity to vary risk tolerance, complexity, uncertainty, the number of vehicles being used, and the type of vehicles being used. And while I believe end-to-end operations can fit under all of these use cases, it's not until we reach the urban disaster relief safety demonstrator or operational evaluation where we may fly kind of a multi-vehicle operation. And that's where there would be this mixture of multiple simultaneous HMI paradigms. So you could have a single vehicle, being remotely controlled, and also multi-vehicle operations being conducted in the same airspace. Okay, last slide that I wanted to go over. So this is the, don't worry, I know you can't read too much of this. This is our OV1 for hurricane relief and recovery. And so we've been working with subject matter experts with experience in hurricane relief and recovery, essentially, and primarily two chief aviation safety officers at FEMA to help identify when would an agency like FEMA want to deploy unmanned assets to support their operation. And what we've come up with, and this is still kind of drafty, but we've come up with is that post-hurricane is where we're most interested. And these are 4 different types of missions that could be of value to them. Looking at surveilling the coast, doing flood damage estimation, urban evacuation, route assessment, and search and rescue. These vary in terms of risk tolerance and time criticality, which allows us to deploy different types of vehicles and different numbers of vehicles across these different missions. Also drawing your attention to what are we actually interested in demonstrating in the Safety Demonstrator Series. In the orange are identified hazards for this specific operational environment. These can range from loss of navigation system, loss of power, unsafe proximity to traffic that we're all familiar with. And then we're interested in the services, functions, and capabilities that are necessary to manage the risk, to manage these hazards. And we have them addressed mostly in generic terms. So in blue, so that's the navigation quality service, the battery prognostics and health monitoring functions, and DAA that we're all familiar with. So just to circle back, what are we trying to do here with this work? The Safety Demonstrator Series is really interested in maturing and demonstrating the capabilities that are necessary to address the hazards specific to an operation, the monitoring, assess, and mitigate, and to be able to provide those recommendations to the FAA, to industry, to the standards committees, to help advance our capabilities and the operations in general. So just wanted to give awareness to system-wide safety. I have been a member of this committee, but have not been active. And I do think that there's a lot of synergy between the work that's being done here and the work that's being done in system-wide safety that we could be, that there's room to be supporting one another a little bit more, I think. So.
Yep.
All right.
Absolutely. And that's a great dovetail to what I want to talk about next. So you guys got a feel for the evolution of where these guys are going, what they're passionate about, what they're working on. Next, I want to do a little Q&A session. I have a couple of questions that I've been thinking about, so I want to open it up to the audience. And I want to wrap up with 1 or 2 more questions. The first thing, and this kind of speaks to summer, where there's synergies here. So while I love this group, we aren't the only game in town, right? There's other working groups, there's RTCA, there's ASTM, there's other folks out there doing similar, yet different stuff. So the first question to you guys is, what do you think this group does differently? Because you've all been part of it, or most of you've been part of it for a number of years now. And what do we add to the larger body?
Well, I can start. One of the other projects that I'm working on is something called Digitally Enabled Cooperative Operations. And there we're looking at a mechanism by which operators could self-separate in the future. This is, again, a paradigm change. This is how you would operate in the airspace in the future that would enable highly automated flights to coexist with the traditional legacy aviation. And a lot of the work that the Airspace Integration Group is doing aligns very much with the work we're doing in that community. We're looking more at a future state, much further in the future, while the Airspace Integration Group, that's the subgroup of this working group, we're looking a little bit more near term, the step after next, what's going to happen after the BVLOS rule is a reality. Where do we go as a community next? There's a lot of synergies between the ideas and the concepts between those groups, and they're cross-pollinating each other. A lot of the people we deal with in industry, Tim is an example, attends our workshops in digital enabled cooperative operations, and he's a vital member of the Airspace Integration Group. Nick Zyla, Brandon Suarez. These are people who are traveling in both communities, and they're using the discussions in one to help inform the discussions in the other. And so while this group is unique in some respects, it is also helping facilitate work in other areas and vice versa. You heard Mark and I talk a lot about ASTM. It's not just because Mark is the chair of F-38, it's because the work we're doing in F-38 is influenced by the discussions in this group and vice versa, as well as the work in the autonomy for aviation group that we're doing, that Mark and I are both part of as well. So these groups are informing each other. And so I see a lot of synergies, and I know I learned stuff from this week's dialogues that they're going to influence the work I do in other circumstances.
Anyone else?
I'm very happy about the human factors, the level of human factors folks interaction in this group. I think that's a very, I don't have quite the perspective and the experience that Andy has, but from the folks that I've met at these meetings, and the introduction and the inclusion of human factors researchers here is fairly unique.
And I'll add to what Andy was saying. The cross-pollination I think is very useful. So I've been a part of RTCA SE228, Jay and several other people, and one of the big areas of focus there is DAA, especially getting ACAS XR across the finish line. That's something within PAVE we're working on as well. But correct me if I'm wrong, but I don't think you can really have end-to-end if you don't have functioning DAA. So this is an enabling step towards that end-to-end paradigm in the future. Similar case for Lost C2 link, which is really my area of focus, is what do you do when that link is lost, especially for a large UAS. I believe the wing representative mentioned, their aircraft can break apart and is designed for that, and that's great. I think that really helps with the safety of it. But you think of a Cessna 208, a Cessna 208 can't break apart like that. There's a very different scale of safety needed in terms of that, and the risk assessment associated with that. So I think SE228 can tie into this group by focusing on the more near term, but then having the eye out for the further term as well.
Yeah, and I'll just add my familiarity with some of the different groups that you mentioned, human factors, that ICAO has their human factors work that they're doing that's incredibly valuable, and then Flight Safety Foundation has just stood up a group. I can't remember what it stands for, but RPAC is
It's been around about 4 years.
Okay, well, they're making it more active. Or no?
They're trying to rejuvenate it
Rejuvenate
again.
it. There, that's where- okay,
You're
right.
exactly right.
Right, and looking at the gaps so that we're not covering the exact same topics. And I value that that here we're talking about multi-vehicle control that I'm not hearing much about in any other location. Issues that maybe exist for all of them that we can, the cross-pollination, be sharing the information across all of them, but nowhere else are we talking specifically end to end. And I think that's a gap that is valuable for us to continue to address.
Yeah, and the RPAC has a specific human factors group, subgroup under it as well. So.
Yes, exactly.
So that gap's key. So knowing what we know in this group and with these other groups, what other gaps are you guys seeing in both research and application, things that we might want to leverage on for next year?
I'll start on that one. NASA's doing some great work, don't get me wrong. Right off the get-go, everybody here has been doing some great work. It's been helping us out, but we're running ahead of a lot of what's going on. And the MDN is one thing we haven't done. We have not allowed any multi-M operations. We have one to N, so one to a large number, but we're still ahead in some cases. I'd like to get more data from y'all on how many can one person handle versus, and then also get into when you start adding more than one person controlling the number of aircraft.
And can I ask you a question about that, Tim?
Yeah.
You say you're not allowing M-to-N.
Right.
But depending on how you define M-to-N.
That's true.
What we saw yesterday at Wing was a room of 5 people with a supervisor controlling a large number of aircraft that they backed up for each other. When one person went on a break, they had a mechanism for dealing with that.
That's true.
So is that M-to-N or is that 1 to N 5 times?
Okay.
And we look at it could be both ways.
No, it's a great question. We look at it as a 1 to N 5 times because their supervisor, you happen to see one there in the room that day, their supervisor is allowed to telework. At this moment, they are allowed to telework and run from their screen at home. I said at this moment, future changes, that probably won't happen.
That didn't come up yesterday.
Yeah, they're not gonna come up. Yeah, they were fully staffed and prepared for y'all. So let's just say that they want to give you the best impression. So I understand. So we look at it as 1 to N 5 times. That's the way we're looking at it. Each person's responsible for their own. Their supervisor just kind of keeps up with who's doing what, and if someone's having a problem, they can step in and help that person. So is that really MDN? I don't know yet. That's kind of what I'm trying to learn from this group. Also, like I said, we're running ahead on something. It was. Can you back up a slide?
Yeah.
You just blew my mind over what you're working on. But for example, the go back, I guess, one slide. There you go. Okay, that one there. Wildfires you've been working on, the hurricane you plan on doing. Do you know about North Carolina?
In what context?
It's a state. Within 48 hours after North Carolina had Hurricane Milton go through it, it destroyed everything. Wing Aviation was down there doing deliveries for us, running multiple MDN. We also approved CADX for them to get out there without C2 because there's no power out there. So there was no way to have cell towers. So they were launching with a known area, multiple aircraft without C2. Now we did that because we know that that whole area was an emergency area, so only certain aircraft fly into it, and everyone knew exactly their routes that they were going to be flying, so they could stay out of it. But what we also permitted at the same time was FEMA to get out there and do their stuff, so they could start surveilling the area and getting aerial photos they needed. And then you had the National Guard come in, so it was kind of, we were starting to get into that. So now I know who I'm going to contact when we have another event come up. I will be notifying you immediately.
Excellent. Well, and to that point, it sounds like I need to be contacting Mark as well, because what I failed to mention earlier is that while we are not doing flight demonstrations of end-to-end at this time, we are doing human-in-the-loop simulations at this time for end-to-end under hurricane relief and recovery, and we are looking at being able to deliver MREs, the packages of water and supplies to people while they're unable to go anywhere. And so yes, and our focus being on the assurance of the necessary services, functions, and capabilities to be able to safely fly these kinds of operations. Yeah.
The North Carolina one was a great incident where it showed how fast the FAA, and with our division being one division now, how fast we can move. From the time the morning call came in from Wing to get them up to start helping people down there, by that afternoon, we had already approved the CAT Act, we'd already approved the authorization, their OPSECs, we'd already approved, looked at everything that they had, they sent us what their plan was, and it was reviewed. They were actually given permission by that evening to start operations. And they already had trucks loaded in from Christiansburg and heading that way. So Saturday morning, they could be up and running. And they did. We're working together. We're learning from us. I've enjoyed this whole week because I've really learned how much NASA is working in the direction y'all are heading into. And I made a lot of contacts.
So Tim, when working with a company like Wing, if you want to bring that to other groups, what do you see as the biggest barriers to entry into getting into the space? You're working with a lot of different companies. What are some of those challenges that are coming up?
Actually, the teams are resolving a lot of their own barriers to begin with. UTM. UTM is for the small UAS at 400 feet below. I want to emphasize this is the only area we're looking at right now. Is that UTM has been the answer. Because up until UTM first got approved with Wing and Zipline, you could not have two operators flying beyond line of sight in the same area. There was no way of doing that. Even having multiple VOs, it gets kind of complex of who's talking, what are they seeing, where's it coming from? Things happen really quickly. So the UTM has been the door to open up to allow multiple UAS operators in the same location.
So now, I appreciate you guys. The answers are great. I still have a bunch of questions, but I wanted to open up to the group to see what questions you guys might all have as we drive towards 2025 and beyond.
So all these discussions, what I take from it is there's a lot of interaction between government agencies and the industry. Where do you see a role for academia? How can we get more involved?
I'll jump in on that. So we have a number of NRAs and agreements that we sign that we provide specifically for academia, and that is a great space for these capabilities to emerge. So we rely heavily on academia actually to come up with some of these ideas and start developing them to hopefully a state in which we could even potentially test them out in our own demonstrations.
So just to add to Summers, in addition to the NRAs, there's the University Leadership Initiative that we have that are quite large research programs involving a team of academia, and it's multi-year. And many of them are looking at highly automated or autonomous flight and end-to-end as a component of their research. And so we're currently in the process of evaluating the next round of awards, which should be made in the next couple of months. And those awards, end-to-end is a component of what we're looking for, and we've solicited proposals on, and we do have proposals from end-to-end in that suite of proposals that we're considering.
And you might want to team with industry on SBIRs.
That's considered very perfect.
I'm a topic manager, that's why I can say.
Yeah. And we do have SBIRs that are looking at, I have one in my portfolio of stuff that I'm working on that is specifically looking at self-organizing among a highly automated flight.
So we do have a few things that we are working on that may fit the descriptions that you were talking about. Okay? Is there a way that we could pitch that through the NRA or something like that? I'm not entirely sure I'm framing my exact ask here properly, but
my first thought would be, reach out to any one of us and we can direct you to, the right websites to get more information on the NRAs, EOIs, SBIRs, but also just conversation in general so that we can talk about where things could fit, what's already being done, because we do value that academic contribution to all of this work.
And then I would just add, in terms of the University Leadership Initiative, we have the auto cargo one that's been associated with PAVE. Through that, we've also been able to get interns to work with us over the summer, over the fall, and having those undergrads, graduate students bring in that fresh perspective, ask questions that, you know, we're so deep in the work here, we think to consider this other option, and bringing in someone with that new perspective is really very useful. So we had a couple interns work with myself and Husni last summer, and they were excellent. So that's another way that we interact with academia.
Yeah, we can have the intern come learn about our processes, learn about what we think are important, and you take that intern back in the fall and say, okay, here's where we're going to start developing a proposal for a ULI award. And yeah.
If I may make one last observation. Place I come from, we are a smallish program, but we do like to think that we are doing some interesting work along these lines. So probably conversation is the way to make everybody aware of the work that we do, and appreciate the offer to at least what I was doing is an offer to talk.
Yeah, and you know, we're always open for talk, but one of the objectives of the ULI program is to increase the diversity of universities involved in the research, that we're not going to the same, you know, MIT, Purdue, Georgia Tech all the time, that they want to see a new crop of researchers and a new crop of universities. So it's actually one of the criteria that we evaluate on when considering a ULI proposal. And through the ULI website, there is a mechanism to say, hey, you're open for partnership. And you can register on that website and say, you know, this is our capabilities and we'd be interested in partnering. We're especially interested in minority serving institution and HBCUs, as well as being involved. And no one here is from a community college, but there's a community college component to the ULIs as well.
Yeah, and in the ULI, I've been associated with Morgan State University has worked with Purdue as part of this ULI. So there's the Purdue, the MIT, they're the big names, but also Morgan State, which is a smaller university, and they were able to formulate basically a joint undergrad master's program where you can get your undergrad at Morgan State and then go for, I believe, a 4th or 5th year, I don't remember exactly, at Purdue, and go to Purdue for research in the summer and have that exchange between, you know, maybe the larger name and the smaller name universities. But that's worked really well. They've had, I think, at least 1 or 2 students already complete that project or that program, and have been very successful with that.
And don't think it's just NASA.
Yeah.
Yeah, I mean, we should be
FAA also has.
What about the TQ program that I've heard so much? Is there another solicitation coming out from the?
The T-Cubed is on the same hierarchical level as the University Leadership Initiative, and the third program there is CAS, Convergent Aeronautic Solutions. So across all 3 of those, there's opportunities, but very specifically in the University Leadership Initiative. We are in the middle of reviewing proposals right now. So I think we might have missed this year.
I missed it. I
Yeah.
missed it.
But yeah, we can absolutely talk about that. And then NASA research agreements, announcements are, I don't know if those are always on the same cadence.
At the NRA, National Research Announcement.
Okay.
Other questions? Well, and to Tim's point, the FAA does sponsor research. You know, I was involved for a large part of my career in the FAA R&D program. They have a little bit smaller pot of money than NASA does, but they have the UAS Center of Excellence called Assure that has a fairly large research program, and it's several, it's almost a dozen universities are involved in that, and they're always engaging more and diversity, and they have a decent slice of the FAA's R&D pie. Let's put it that way.
Also, if you were paying attention this past summer, we had the reauthorization bill get passed by Congress and got signed into effect. That increased the STEM. It used to be just high schools. It's now loaded all the way down to elementary and middle schools. And we are supplying them with stuff. And we've also increased the number of colleges and universities. We have a lot of community colleges that are doing stuff. We have small universities that are doing stuff. And just as they're doing interns, we do too. I've worked with several of our interns before, so we bring them in for the summer and see what we're doing and also what research is going on.
That's good information. Embry-Riddle is part of the Assure program.
Mhm.
I'm
Yeah.
supporting an Assure project.
Oh, and while I'm on the subject, since you brought it up, if you're a college, university, whatever, and you got students that are looking for internship, come January, go to usajobs.gov. Any government agency has got to place them on there, and there's a spot you can link on, and it brings you down to the internships. And then you can look at just the internships, and it has two different types. It's got the internships for still in college, and then it has the ones that are also fresh graduates. And some of them might want to look at those. And when it comes to still in college, it's broken down even further into undergraduate and also graduates. And we do use all those.
Any other questions from the group?
Okay. One thing that we've talked about a few times, but never really pushed very much, is somehow developing. We know that wing and zip line are out in front, and some of the things that they're doing are proprietary. But I think there's probably a need for sort of a clearinghouse of data that they have, or lessons learned that we could start to put together. And it seems like the government would be the right facilitator for that kind of thing. Do you think that's a worthwhile thing to pursue and make into a formal kind of agreement with those folks? Or
I would 100% love to see NASA communicate with us, because we have every single operator, all 5 of our commercial operators, even our ag operators, have to provide us with a monthly update. And that monthly update includes the number of land nows they've had to do, number of times they've had to deviate because of DAA, number of times that they've lost C2, the number of flights they've accomplished, how many flight hours they've accomplished, any failures, incidents that they've had. It's a laundry list that we have that they have to capture each time. And they send us on a monthly report. So.
I think that would be really useful. I mean, we may have to de-identify
where
the data is coming from and all that kind of stuff, but we have experience with doing that, right?
And the list that I just gave was actually a small one, because part of the FAA is AUS, and they collect even more stuff. And I'm surprised that we haven't coordinated already with all that.
But yeah, so to your point, for large UAS, PAVE is currently working on developing what is been called several different things, but we sort of settled on the Hollister Airspace Ecosystem. So Hollister, California, about an hour south of San Jose. There's a couple different operators who already operate there. We'll be working with at least 2 of them. The idea is, can we take some of the existing, or take the existing NAS, introduce these new operators into a real environment and figure out what is needed to actually get them across the finish line to operate in a real NAS. So we're not blocking off airspace. We're not, doing anything like that. And as part of the agreement, of course, we have to be sensitive to their intellectual property, but, as NASA, our duty is also to share that research. So this is some research that we would share with the wider community, certainly with the FAA, once we get up and flying, hopefully late this year, next year. We'll see how the airworthiness process goes there. But that is something that we're actively working on. And the idea is to start with the large UAS, but also introduce some of these associated elements or third-party services see, do we actually need a ground-based surveillance system for DAA in the terminal area? No, let's test it out. So that's something that we're actively working on.
And I already know about the Hollister one because we're already working on internally on our side. We just need to connect.
Yeah.
One other question I have, as we've been talking here, it's kind of cool looking out over here. There are some new faces, which is always good to see. As we go into next year, as we want to expand this group and continue to see it thrive, are there other vendors that we want to bring in? Are there other groups within the government that we should be talking to, other folks that, or bodies of knowledge that we should invite in here to help continue this group to flourish?
It would be nice on the FAA side if we could see how they're working with y'all. Many of the other operators that are out there, you've talked about Wisk, Archer, Joby, they're all going through different testing. Those are just to name a very few, but we have a laundry list. I think right now we've got about 45 different manufacturers that we're working with on going through certification and what's going to take. And it would be great to hear from y'all's side point of what do you see or what are we missing, and so we collaborate.
So is there, how should this group be announcing that opportunity? Because I think there's probably a lot of startups that aren't even aware, right? This channel exists.
Yeah, I think that Nelson makes a good point. The other thing is, and when we had our industry panel up there, I think, George thanked them, made it very clear that they spent the time to be here. How do we, there's a lot of industry people who have been participating, but it requires an investment of their time and energy, not just the cost of flying and all that. It's their time, it's an opportunity cost. It's time they're not spending on other stuff. I know, people like Tim, he's got a lot of stuff on his plate, but he spent his time here. We have to make spending the time here valuable and worth their time as an investment. And that, I think, is going to be a key. I think industry is aware, but we have to make them aware of how it might be valuable to them. And I think that's going to come from other industry people saying why it's valuable to them, to get them to participate.
We've got to crystallize that value proposition. And I think that is centered around the conversations we're having here and the products that emanate from that. I want people to understand the value of these conversations and know that they should be here to provide their input. The things that we're producing, people are going to pay attention to them. Maybe some decisions are going to be made based on those things. And it's vital if they want, for their vested interest, to be here and to participate in that. That's at the heart of that value proposition, I think. But certainly communicating that in a better way
And we have done sort of outreach at AUVSI, and we have panels there, AIAA, et cetera. And I think, that's one place we try to make that connection with other operators.
But also, Nelson, to be clear, everyone in this room is important, but this is not the only part of the working group. We have a bunch of subgroups that have been meeting mostly virtually, doing work, and there's a lot more industry participation, which is critical to those subgroups at the subgroup level, and that has been regular. And it's not just industry as in new entrants and proponents. My subgroup, we've had outlet at the table, quite actively at the table, which has been critical to the dialogue we've been having in that group.
I think associated with that is something we've done within PAVE is we had a tabletop on end-to-end, and we brought in air traffic controllers, dispatchers, military remote pilots, conventional pilots, and got all of that feedback. I think incorporating some air traffic control side would be very important. So somebody from NAPCA potentially.
My group does have NAPCA.
Oh,
Able to.
Yeah, so that and then the dispatchers were brought up before. I think the role of the dispatcher is very similar in a lot of ways to what a remote pilot or multi-vehicle supervisor, whatever you want to call it, might end up doing for some of these operations. So that's a really good resource or voice to incorporate, I think.
I did actually speak at the last, the Airline Dispatchers Federation a year ago. They have an annual meeting, and I gave a talk about, the future of aviation. And I actually talked about this group and about how we needed dispatchers at the table. They were interested, but again, what's the value proposition to them? What table do they need to be at that's critical to the missions they do? And they didn't have anyone raise their hand to become part of this group.
Partnerships are so critical from a program perspective.
Amen.
I mean, if we don't have partnerships, who are we doing the work for? I mean, that's what Congress is going to come back and say, well, you guys are playing in your sandbox, forget about it. So we really stress the value of partnerships within our program and within the agency.
Yeah, to add to that point, all the work that we're doing under system-wide safety, if we don't have industry, if we don't have those partners reviewing what we're doing and providing us feedback, it's not as valuable. Really a huge part of the development is getting that feedback to say we're off course, or no, this is valuable to us, continue down that path.
I think that's a part that a lot of operators out there don't understand is that when it comes to certification side that we're looking at, well, you want us to certify this new theory, new product. How do we do that? Is it safe? That's our number one responsibility, is safety. Is it safe? We don't know, because we've never dealt with this. MDM is a good example. We've never had MDM before. That's new. So
yeah,
how does it work?
Well, with newer systems, more and more software or cyber physical systems, right? Now we're talking about AI and more complexity. We're still trying to develop methodologies to do that assurance of autonomy.
Well, and so that is the work under system-wide safety, and specifically sending it over to China Farm there for feedback, because it's your feedback that helps us course correct and make sure that we are providing some recommendations of utility.
Great discussion, guys. I think we have time for one more question from the group.
So do you have a plan for feeding back the learnings from this study into standardization organization? Obviously, there's going to be a tremendous amount of really good learning about particularly the human machine interface and roles and functions. How do you see that making its way into standardization?
That's a great question. Well, go ahead, Jordan.
Yeah, so from our perspective, we're actively working with SC228. We attend their meetings. Got a couple people on our team that have set up a lot of the simulations and the scenarios for DAA testing, for example. The work I've done with Lost C2 Link, and hoping to outbrief to SC228 sometime soon. That's the major way I think that we're operating. We've also sent some people to ICAO in Montreal a couple, I guess it was a month ago or so now. So been doing some interaction that way as well.
And I will actually point to our moderator. Scott is the co-chair of the Human Factors Committee, technical group, task group, I think we call it, under F-38, ASTM F-38, specifically looking at the ground control station design issues that would facilitate, safe operations. And F-38 right now is majorly focused on the standards that the community needs to enable the BVLOS operations that will be enabled under the NPRM that will eventually become a final rule. That's our emphasis. So we're trying to make, what are we going to need to do across the board in terms of technical standards, and then it includes the human factor standards, the UTM capabilities, and specifically looking at highly automated flight and how we might have to change the standards we've already published to better facilitate highly automated flight. And that's what that F-3801 meeting is about at Wing in November. So, all of these things are tied. Scott, Wendy, who's I think still online, is the other co-chair. She's been participating in this group. There's a couple other players who are also involved. So
Yeah, and as you know, we wrote a white paper for SCT 28 on just, sort of getting the concepts out there, and Garrett's helping finishing that up now. I know you made a lot of comments on it, so I know you've seen it. But that's one of the ways we're just trying to socialize these, this kind of con-ops and let people know what's coming down the line.
And I say system-wide safety, we have involvement in many of the standards groups, most of the standards groups. But I'd be curious to know if there are organizations that we are not a part of that we should be. If people can identify that, because what's being addressed out there yet that we don't have somebody somewhere tied in.
All right, guys, thank you very much. It's been great. Thank you for your questions.
Okay, we are slowly getting there, guys. You got to hang in there for a couple more discussions. One is, I think you all know, this is my last meeting, and NASA has contracted with Aptima to come in and take over and probably do things right. And so I want to introduce you to Samantha Emerson, who is going to come up and talk a little bit about and introduce herself, and let you guys know where we're headed.
All right, will you cue up the 30 frame slides? Yes, no, I'm gonna just take like a couple of minutes. So my name's Samantha Emerson. I'm here from Aptima. Like Jay said, he will sadly be leaving you, and sad because, oh my goodness, what an intimidating set of boots to fill. He's done a fantastic job of getting this group together. I've been super impressed by just how amazing this group is, how collaborative, how open conversation has been in like some of the breadth and depth of topics that you guys have covered. So me and Kara have been taking notes in the back. We have some ideas on the types of topics we've heard you bring up that you guys are interested in tackling. I'm sure we'll be hopefully on contract soon. So we'll be reaching out to you guys, trying to get your input on what you would like to see coming out of this group next, the topics you'd like to talk, to really delve into, the types of speakers that you think could help fill in some of your gaps of understanding. But also, I think we're going to spend a lot of time of just synthesizing the information that you guys have gathered and pulled together so far to really look at and see what this kind of bigger framework is, and hopefully use that to guide the direction of this group after these white papers are published. So we'll reach out to you, get more in depth about like what you guys would like to see. I would love to get some input if anybody has any ideas. The next one of these should be around like April, May, June timeframe is what we're planning on. So I would love to get feedback on if anybody has any suggestions on places you would like to go. I would personally, I thought the wing demonstration was great. I think like if we could find volunteers, maybe I see some folks around here who might also be willing to talk to other companies about demos. I think that would be great. But does anybody have any suggestions on places or facilities that we should reach out to look at? And Langley, I know, I think you guys have been to that center before and seen the Rome Center, but maybe other places like that. Big question, right? Yeah. And we'll be reaching out to folks to see if we can make some of those connections. The other thing that we would love feedback on are conflicts, like conflicts, major conferences that you're attending, other types of events in that time frame. If there are anything that you guys would probably rather go to than this, let us know that we can avoid. And I wish, if I would have thought about it, I would have put my email on this screen so that you guys can connect. But I'm semerson@aptima.com if there are ideas that you want to send out to us.
I think this meeting could go over pretty well at a university.
Yeah.
NASA centers are always good choices as well.
Okay, yeah, definitely. We've got a couple of academics in here that might want to host.
Yeah.
Thinking about it, I'm not gonna commit to my university. But it's definitely not, and we are centrally located in St. Louis, so we do have, we're not too far away from large Midwest universities like Purdue or Illinois, Missouri, or SMT and places like that.
Yeah.
Would be a possibility. Yeah, we need to.
Of course. Yeah, I'm not gonna obligate anybody at this point, right?
And I think, Sam, once we get some consensus on the topics,
Mhm.
we may choose to reach out to, we bring in any academic speakers on some of those topics, they might be willing to host us as well.
Absolutely, yeah. Yeah, yeah.
For your information, the Expo, AU BSI Expo is in May next year, the 19th through the 22nd. So I don't know if you want to go to that, it's in Houston, Texas.
And which conference was that again, Faith?
Exponential.
Exponential, gotcha.
That's the biggest.
And this meeting has been like adjacent to that before. Right?
We
had a breakout
Yeah.
session at Exponential.
Yeah, we're having a working group along with it.
Okay.
Because there's competing.
Sounds like a good idea on the surface.
Nelson, you have attended a EMT, first responders.
Oh, yeah, the drum responders, that was part of the UAV Expo. That was
UAV.
my first time with them, I don't know much about it.
That must be very interesting.
ABSI is a lot better.
Yeah.
But the drum responders, there's a drumresponders.org, and then there's a DFR, Drone as First Responders Working Group.
Mm-hmm.
And I just recently attended one of their meetings, and there's different FAA people connected to them, so, following that,
Other good communities to try and bring in.
Excellent. So if there aren't any other thoughts, I'm not gonna keep you guys. I know that you guys are eager to go get lunch and then also to see the rock.
Right.
So I don't know if we can, start that demo earlier if we have a specific slot to go see that.
We were set up for 1 o'clock. Let me see if Doug is able to come down and start us early.
Yeah.
Okay,
All right.
cool.
Looking forward to being able to work with you guys.
Thank you very much. All right, just to close out, several thank yous. Jonathan, as always, thank you very much. You did a great job again. And we appreciate it. Thank you to Tim and the FAA hosting us. It's always nice to see have facilities that can allow us to come in. We have a lot of work left to do on the white papers. And while this is my last meeting, I'm really going to try to facilitate getting the white paper that I've been leading into a place where it can get into a review before I completely close the door on things. But after saying that, we're more interested in doing it right than doing it quickly. And so, like I was saying when Mark brought up, looking at a different scenario and showing that the metrics can apply to that scenario, I think it's probably worthwhile to try to address that and do that within the context of this white paper. And we still have to determine if and how we're going to integrate the exceptions white paper. And so there's a lot left to do on these. And sometimes the hardest part is the finishing part. So hopefully we get that done. So this is my last meeting. So thank you all for coming. I have appreciated working with you all. I've really appreciated all the funding and support from NASA that has allowed us to put this together and allowed me to continue working in this area. So thanks very much, and we'll see you down the road.
Thank you, Jay.
And thank you, Jay.